जय हे भारत संविधान, भारत भाग्य विधाता। जम्मू कश्मीर हिमाचल पंजाब हरियाणा राजस्थान दिल्ली यूपी उत्तराखंड बिहार गुजरात महाराष्ट्र द्राविड़ आंध्रा तेलंगाना कर्नाटक केरला वंगा विंध्य हिमाचल तावी सरस्वती गंगा यमुना ब्रह्मपुत्रा कृष्णा। तब शुभ नामे जागे, तब शुभ आशीष मांगे, गाहे तब जयो गाथा। भारत सर्वधर्म नागरिक भारत विधाता, जनगण मंगल दायक जय हे भारत संविधान, भारत भाग्य विधाता। जय हे जय हे जय हे जयो 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 हे। जय भारत वंदे मातरम, जय संविधान। सुजलम सुफलम मलया शीतलम सहस्या श्यामलम मातरम वंदे मातरम। जय भारत। Dear friends, again back to you, Suraj Singh. Speaking from Faridabad, NCR, Bharat, India. Project management, day-to-day requirement in engineering and elsewhere. Project management engineering is very vast, very vast. It's not simple management. It's very complicated, diverse management. It's not simply business administration or business management, but activity-based technical management and controls management. It's design management, practical activities management, control management, cost management, and there is no end. And it's different in every different field of construction, civil, and in other engineering. It involves many disciplines of engineering. We may not imagine sitting off construction engineering. Means management term here is little misleading. Misleading in a sense, people try to take it to construction management linked to business management or project management in general. Project management in engineering is not general management. It is very different management. It is a kind of very practical specialization that requires to be known to an engineer. And it's not given by books. No book can make you a manager in engineering. It's your engineering knowledge, it's your training, it's your practical experience that can make you a practical management, which cannot be specified, cannot be designated by any certification. What you deliver per requirement is a kind of, you can say, feeling that I have done something. When engineers deliver something to public, it feels that yes, something has been done. It's no imagination, it's no hypothecation. It's practical work delivered which shall be used for decades and in some cases centuries. That delivery is different. It's not simple mobile phone or simple any article which is gadget which is delivered for a few years, 1 or 2 or 3 years, and then destroy it. It's not that. It's something where people are going to live in that. People are going to use that. That means you are born in that building and you may be old in same building. means lifelong use product it is. So should we take it so easily? A building you construct for yourself, you stay in that building for 50 years, your children may stay in that another 30-40 years, and it may then another generation may stay in that. What do you think? That product is nothing? Should you not care for that project during construction itself? Should you not properly plan that pre-construction stage? You have to. If you do not, you miss something. After all, it's your money. It's not free. When you go to buy certain vegetable in market, or some other commodity, or even if you buy simple mobile phone or some other article of home use, don't you think that, don't you scrutinize that? Is it worth your money? Does it have quality or durability or no? You see that. You are very much concerned with that small amount of money, but you are not concerned for that article, that product which you are buying and shall be used for decades to come, and that is your building. It may be commercial, it may be residential, or it may be flyover public use, it may be some other structure, it may be even storm drain, it may be sewer line, it may be whatever you can say is for public use. Even railway track, even roads, all must be taken care of by management, to be conducted by engineers and not by somebody else. And I am very serious about this statement, because this is quality management, this is engineering management, this is technocrats management. So that educational training and then pragmatism and attainment, one should be strong enough to assess of activities done by self, by engineer. Engineer doesn't mean you have a certificate and you say yes, I can seal this work. It's not question of sealing and drying or whatever work done. Question is how you are sure that your work is worth, your work delivered is reliable. That is a big question to be defined. Do we do that? I call this term reliability. See, you have to decide what you want to do. And according to reliability, it means safety or safe work, work that delivers service or serviceable work, service, it must have service power, successful power, and it must be durable. This means reliability is equal to safety plus serviceability plus durability. These are three important factors that must be considered together in addition to secondary factors like robustness, like this. All same means basic factors are these. If you take care of safety, safety doesn't mean safety on site. This is safety of product. Product that you receive must be safe. It must serve for intended purpose for which it was designed, and it must be durable. Safe means it should be strong enough, it should be according to your design, it must be very excellent in its service, and it should do service, and it should stay in service for a number of years which were taken into considerations while design was done. If it is for 50 years, if it is for 60 years or 100 years or 30 years, whatever numbers are taken, it should work at least safely and with service up to that period. And if it's about that, by continuous retrofitting or continuous maintenance or continuous strengthening, it may move more. That should be kept in our mind while working as engineers. And it should work both in design as well as in execution or prosecution. This point is very important. It has been seen, I have personally noticed and observed, based on my knowledge and experience, whatever small I have, that we have been missing something in construction engineering in ours, and which is unbecoming actually. I feel sometimes very bad that we have so many universities, so many colleges, regional colleges, IITs, and many institutions, yet standards of construction have not come up to that level we should have. It's really regretful statement I'm making, but it's fact of life. You have to accept truth if you want to improve. If you say everything is okay in ours and nothing is okay, then it is foolish statement I can say. Engineers are educated people, highly educated people. They must take responsibility and speak clearly. No diplomatic answer. Because we are dealing with people, we are dealing with lives of people. We cannot simply pass excuses to others. We cannot say that they are responsible and we are not responsible. Because engineering is something very different in comparison to all other professions. You are working for project, for products which shall be used for people, and it's question of their livings and life and death. And moreover, your projects are far off from people. People in fact do not know what you are doing. It's not only here, all over the world. Because we fence all construction sites and people don't know what's going on, and we don't want them to know because they will come and interfere on work. But question is, when people are not watching you, you have to watch yourself. When there are no one to pinpoint, then you have to pinpoint yourself. You have to claim the way you have done is right. This is what quality system says. We have not understood quality system so far. We have just understood certain controls which are verified and ratified by certain conductance of tests, and that's not quality system. Quality state of construction, in particular in concrete world, in ours is not to a mark it should be, and I am speaking for all projects generally, except few you can say. We are spending 60 to 70% of our budget in all states as well in center and in private sector on to construction. It may be real estate, it may be road, it may be flyover, it may be railway or whatever it is, means concrete element is involved everywhere. I am not talking of brickwork, I am not talking of block work, I am talking of concrete, because others are ready-made products. Bricks are ready-made, blocks are ready-made, quality control is entirely different in that case. Better quality can be maintained, but I am talking of that product, that's concrete product, RCC product or pre-stressed concrete product, cast in situ product, which is used all over structures, and unfortunately it's not taken due care as it should have. This deficiency is not understood by people. I don't understand reason behind that. People are not very serious. I have attended many seminars, many conferences, I talk to people, but I don't find any degree of seriousness among professionals. Forget non-professionals. I'm not talking of workers, I'm not talking of foremen, supervisors, all those who are not well trained. I'm talking for those qualified and educated, high-profile people. They may be from whatever institutions, it doesn't make a difference. Standard of thinking remains same all over. They are very, very interested in designs, in planning, and a lot of people are not interested to a required degree to an extent. Prosecution, execution, elements and activities are concerned. This is very serious. And even for smallest work, small sections, for example, stove water drain, it's nothing, means very small box, and they cannot do quality work on that. It's unfortunate. Forget about buildings and structures, high rises. Of course, I cannot blame everywhere, but general is same. General contemplation is same everywhere. And or you may say that I am talking excessively, you may say that. But facts cannot be hidden. When I walk on road here and there and find some activity and see what's happening there, actually engineering technology is far away from public. And it's fault of engineers, engineering institutions, universities, all that. They are all in cities. Universities are in cities, colleges are in cities, all are watching and no one is speaking. Nobody is interested to speak. I am not blaming politicians, I am not blaming others. But at least engineers are supposed to improve performance of all. But no use. You may write journals, you may write papers, you may conduct seminars and congresses. It's all formality. Nothing is reaching to common man. And common man does not understand anything. Many people come to me about building design. I say, okay, we'll do. But they are only interested in certain line diagrams. Give some lines, plans, and that's it. They will do themselves. This happens with me. Somebody comes, okay, I'm constructing this one. Just give me lines. I have to do it, and I'll do myself. They are so confident that they don't need the engineers. Even if you tell them, they say, no, we will do. I'll sell this. I will not stay. This is not my product. So I don't care for it, how it is designed, how it's constructed. If that tendency exists in people and public, so you know what future these buildings do have. There is no meaning. I cannot blame other professionals because we are blamable. Yes, I can directly blame architects, but why should I blame them when we are wrong? We are at fault. Whether we work in government sector or we work in private sector or we work as freelancer, I think contemplation is same. Nobody is so serious. Yes, you have very degrees, you make claim, I have done PhD, I have done MTech, I have done BE. You have done nothing if you are not able to deliver what is expected of you. This equation must be understood that way. Your certificate is toilet paper if you cannot deliver what is expected of you, and you can simply say, what can I do? System is like that. If you cannot fight, if you cannot contest with everyone, you cannot produce. Engineering construction is not that as we think it is. Workers are useless. Workers means construction workers. Nobody understands anything. Even you want to explain, nobody shall understand. This means culture has changed. But same people, same persons when go overseas to Gulf or other countries, they work there according to requirement. This means they are forced there, they are supervisors, they are foremen, they are general foremen, they are engineers, and there are others who control them. This means fault lies at control and not at public, or not at people who supervise or who do job. So whose fault is that? I think professionals are at fault. Our professionals are at fault, not only civil but also others. I consider professional engineering in main branches like civil, electrical and mechanical, and you can add to that architectural engineering and not architects. Because architect engineering and architect are different fields. Architect engineering includes civil engineering, whereas architect doesn't include civil engineering. There's a little difference, but don't confuse with that. These are basic professionals for construction engineering, and others are supportive. For example, IT, CCTV, SCADA, and others. They're all supportive. So my concern is limited to civil, electrical, mechanical, and architectural. Okay, as far as structural is concerned, structural engineering is concerned, architecture keeps off. Don't worry about that. But mechanical, electrical, both are responsible, whether it is structural concrete or it's structural steel. They all are responsible. But to what extent are they responsible? I don't understand. I have seen many excavations in private sectors. Just they excavate down to 15 feet, 20 feet, 5 meters, 6 meters, and there may be 3 buildings around. They don't care for that. They leave embankment free of any support. No supports, but they leave embankment. Luckily, soil is like that. Clay soil cannot subside immediately. And even on that they put surcharge like steel they bring and put there. Or something else, which they don't even think that these buildings on three sides or two sides make subsidize. They don't care for that. They may subside, but there is no one to do. After there must be some architect or engineer there behind scene. But I think that guy doesn't go to site. You bring bundles of reinforcement and put on that. You bring 10 bundles, say 10 ton, 20 ton load you put on that, the surcharge on that filled, excavated earth and surrounding that the sun can't. It take risk and so there's rain, it happens. Nobody cares. And certainly those existing building would sink unnoticeably. But nobody cares here. Nobody cares for formation. What happens to that? No compaction, no soil improvement, nothing, and no soil testing. This is real estate of our nation, and it's for all buildings, not for one. Private sector, government sector. In government sector it's worst. Okay, private is of course worst, but I cannot blame, there's no one. In government there must be people. How many soil reports you have seen? I saw many soil reports when I was overseas, but here I don't find any report. You don't think, even if you find some report, it will be by some IIT guy or somebody who doesn't know anything practically about engineering. They are professors, I am not charging them, but their knowledge is limited. They are not experts of practical world, but they sign certain reports as issue that. I have seen some professors who issued proof checking on seal put by contractor, design contractor, and they issue just without going through that what is there or what's not there. They don't even worry about specifications written on drawings, and sometimes nothing written on drawings. And guys who are on site, responsible supervisors, they do not understand anything about that, but keep on moving and moving and moving. This is really very serious state in concrete world in our country. And concrete is an element which is very responsible, but is actually real element in building. This constitutes anatomy of your building. Anatomy, I want to say, if this doesn't exist, your building cannot stay in. It cannot stay in. I am not talking of pile foundation, I am not talking something else. I am talking of ordinary building, which are simply spread foundations and soil below. Ordinary soil, clay soil for example, or sandy soil is very limited. Clay soil, rocks are also very limited. And normal framework. They do not understand any framing. They don't have what is framing. They don't know. And no one is to tell them. Who shall tell them? There must be some architects who prepare designs, certainly. And I cannot expect architect, and these people are not interested in design engineers. That is a real problem here. And I am not saying that design engineers should be paid or what should happen. The question is that after all it's building that's going to suffer. It's no one else who will suffer. Public shall suffer if suppose this mishap. I have seen many cases recently, the buildings tilted and considerably tilted, not simply tilted in millimeters, visibly seen they are tilted. How does this happen? Have you ever thought of? Nobody thinks. Why should someone think? Let it fall, ask occupants leave it, vacate it and go, and let building fall, or they will wait until it falls. Where is profession? I am not talking of who is responsible. I am talking for two people here. One is owner of that building and other one is professional who worked on that building. Both are responsible. Owner wanted to save money to be paid to engineer. Okay, you save money. But ultimately, are you really saving? Question is that, are you really going to save that money? If your building fails after 10-15 years, it tilts, are you saving money? And you are lucky that it tilts, it didn't just collapse. Where are you saving money? Why don't you do it professionally? What do you want to save? How much shall you pay to engineer? How much shall you pay? You are paying to architect, okay, you pay, no problem for that. But why do you want to save money to another professional, from another professional? You are also paying to electrical person, you are also paying to mechanical engineering person, lift person, to everybody you are paying, but engineer is your enemy? Okay, then you want to take risk of your building. You don't understand soil investigation, you don't know what's property of soil, you don't know what's value of foundation design, you don't understand materials, you don't understand formwork, you don't understand reinforcement, how to protect it, how to save it. You are allowing rusted steel to be embedded in. Now, after all, why are you going to take public at risk? Why you take public at death? You won't be there in that building, but people will stay and they may die. So who is responsible for that? You will run away. That's what I am interested to talk about. In quality world, because it's series of quality, I am talking of management, and quality is a part of management. In management, project management, we have ownership, we have engineer supervising, and we have contractor who does it. This I am talking about in this series. So I want to talk with intensity about quality of controls of concrete, because concrete is prime element. If brick wall collapses or it cracks or block collapses, it doesn't let building down. It's only concrete that fails, your structure will be down, all your finishes will go away. How much money you spend on finishes, that would go to zero. But if collapse of structure happens, you have a lot of problems. First, it is loss of natural material, because concrete means aggregates, cement and water all go waste. Steel go waste, and lives of people go waste. So why do you spend money for all such accumulative losses? You may say it happens 1 in 1,000 buildings. It's not that question happen in 1 in 1,000 building. Suppose there is fire break, your building is on fire, and if in 10-15 minutes your building collapses, it should not have collapsed before 2 hours according to designs, but it collapses in 10-15 minutes. This means there is a lapse. You have designed, you have spent money on your building to deteriorate immediately in fire. Was this your objective? If that is your objective, then I can't say anything. Why I am telling all this to all those people who are interested in getting good work by spending their money as investment on this. If you think your building is only for investment of money and you are not going to be responsible for that, you are in wrong world. You are in wrong stage. Even if you use this or you don't use this, doesn't make a difference. After all, it's building. That engineer who designs shall not think that if it's going to be used by this person or that person. Whoever user is there for design is same. And you take out from your mind this concept that because I am going to sell this building or I am not going to use this building, I don't care for its design, its quality. I am just investing money for benefit, for profit, for residual income. If that is your mind and your mind is default, your mind is defective. Sorry. Your mind is defective. Quality of concrete is very important factor. Whether you do cost in situ work, that cost in situ I mean to say work of concrete done at site, and pre-stress is something means production of equipment, beams, columns and slabs are done in factory, so-called yard, and from there these are transported and placed on site. Generally, in fast track projects, columns and beams are cast in situ. You mean these are produced by cast in situ methods. Foundations, columns, beams, they cast in situ, and slab panels they produce in factory and transport to site for erection. Whereas cast in situ exclusively means all concrete is done on site in cast in situ way. I mean to say concrete means formwork which is called shuttering, and it is reinforcing bars, or we call steel rods, the people call bars or rods, whatever you call it, reinforcement engineering we call it. That's another activity. So shuttering, that's formwork, and steel, these are two activities, and then concrete is third activity, and curing is fourth activity. When formwork is there, you have to remove that formwork, because that's called de-shuttering, people call it. Steel remains inside, it doesn't come out, and you produce it, and it takes 7 days, 28 days for strength, and then years to go. Means your liquid of concrete, your fluid concrete that you produce on site or you get from batching plant, this liquid, hydraulic liquid, fluid, this solidifies into stone and steel is inside. This is called RCC. We call it RCC, means reinforced cement concrete. Maybe for information to people only, not for engineers. Concrete is very good in compression, means if you press it, it will not break. And it's not very good in tension. Tension, I mean to say, when you pull something like this, it's called tension. And when you do like this, it's called compression. Tension is compensated by steel or reinforcing bars, and concrete takes compression. This is a simple theory. It's not very, I mean to say, simple statement for your understanding what we do, for why we use steel in concrete. And formwork means it takes liquid product and allows it to solidify. This is concrete. And curing means is a treatment, name itself says curing, means there is some deficiency in concrete, it is replenished by curing. There's chemical reaction between cement and water that it results in evaporation of water from itself, and that evaporation is compensated or replenished by addition of curing water. This is a process which takes many days and sometimes months, and your concrete gets solid and solid further and further. This is a simple answer. But technology is very complicated. It's not 1940 or 50. It's 2020. Concrete itself is a vast technology. It must be understood excellently even by public. Don't leave it to engineers alone, and engineers must make use of that technology which they are missing. They know technology. I don't say they don't know it. They know it. But ignorance, carelessness, and just let it go on. They say, let that person would do this. They say, okay, supervisor would do and that person would do. They believe that much. Okay, they would do if they are reliable. If they are not reliable, then I have seen many locations where concrete was ongoing, but there was no responsible person present on that site. Just some contractors present, and you cannot trust contractors because these contractors are not very well qualified. They have no registrations in public institutions. They have no professional qualifications. They have no such tenets that we can say that they are professional. Then what to do? If there is no control, then public has to control itself. But I cannot say public would control without having any information. Who shall give that information? You have to take by your own. But how? Just for this, I thought to talk through video to people. If they are interested, they may understand. Concrete definition is very simple. Concrete, actually, if you just think of meaning of concrete in general, in academical or article way, it means something solid. You say, okay, this your work is not concrete. Sometimes you say, oh, give me concrete information. We say like that. I want concrete information. I don't want liquid information. Or I don't want soft information. I want concrete. Give me concrete result. It doesn't mean concrete material there. It means a state of that information which you are intending to get. This means that's solid. That's not liquid. That's not fluid. That is reliable, it means. So here is concrete, which is a solid product, artificial stone, you can say, It's not natural stone, but produced by using natural products, natural resource products. For example, rock. What is rock in this? In concrete, we are using rock particles like stone aggregates. We are using the stone aggregates. We call, in Hindi, we call rodi sometime. Means these small particles of solid limestone or granite. Both can be. There can be limestones, there can be granite stones, or in Gulf there may be some others, gabbro and so many. Igneous rocks particles, or limestone particles, or sandstone particles. There can be different types of aggregates. So better if we have igneous rocks particle, but those are not available. So limestones are generally used up to 20 mm size, or you can say up to maximum 1 inch or 25 mm, 12 mm, 10 mm, like that size. And sand or dust, stone dust you use, also stone dust from crushers that come. So ultimately it is natural material. And you use cement, you call it cement. Now OPC, they call it, OPC is very old term, ordinary Portland cement. Nowadays it's rarely used. We call it cement, but this mixed with some other particles. Cement also comes from limestone, silica. This is basic ingredients of cement. 66% is lime, there at least 60 to 70%. And silica and many chemicals are there. So that too is chemically produced natural resources. And then there is water, which is also natural. So it is completely natural product that we are using as ingredients. So it is lime, it is silica, it is stone, it is dust of stone, it's or sand, river sand, or you can say pit sand. Many ingredients were available, are still available. And then we add chemicals onto that. So this is completely inorganic material, no organic product in that. In this world of engineering construction, organic products are not welcome. Organic products means green products, leaves, fruits and all that, which we consume every day. This is inorganic world of engineering, where minerals may be there, inorganic chemicals may be there, no organic. If there is some organic material, we have to take it out, we have to extract it out. So concrete is a combination of these stone, dust, rock particles, and lime and silica and chemicals. So many products are there along with water. Think of what sort of this is. And then there is steel on that. Steel is also very inorganic material. Chemical means a kind of having so many composition of carbon steel. It's called, we are using carbon steel. We may use other types of steel as well, but carbon steel is generally used. So we have to think it in this way. It's not simply mixing of something and doing on site. It is a complete technology. And moreover, as I said, concrete is very good in compression, and also steel is very good in tension and compression both. But what is reason that we use steel bars in concrete? For public understanding, reason is very simple, but for engineering understanding, they know everything. I don't mind to tell them again. When there is heat or thermal application, with a heat application on whatever part of concrete body, it may be column, it may be beam, it may be slab. Let us say temperature is 45 degrees, 50 degrees, and there are changes from morning till evening and all time. Thermal stresses are applied, thermal forces apply on your concrete, and when it's cold, also cold temperature applies, negative thermal energy applies onto concrete. Because it is natural product, there's a tendency in this not to resist 100% but to move from its actual position. Movement cannot be seen by eyes, but there is movement. And there is a shrinkage also. It depends upon temperature conditions. And this is called movement of concrete in its existing state. Movement of concrete material, I should say, member, I should say. There's expansion as well as there's compression. This must be understood that it's not stationary permanently. There's always some movement, and that movement causes friction, fracture, stresses, cracking in body of concrete, which must be taken care of by something. And this expansion for steel bars and concrete are approximately equal in calculations, equal in coefficient. When I say coefficient, means equal efficiency, same efficiency. If concrete expands, it moves, steel also moves. This means both work together. Concrete material produce concrete material, solid material of concrete, and steel reinforcing bars move together in same value, and there is no conflict between this movement. That is an only reason we use combination of concrete and reinforcing bars. We call it coefficient of expansion. Coefficient of expansion, linear expansion. If say concrete moves for 0.01 millimeter or 0.02 millimeter, steel shall also cooperate with it, co-pilot this. That is reason this combination is accepted in both types of concrete, cast in situ concrete, precast concrete or pre-stressed concrete. This is what you should know. Reason that we use this material. Well, this is just fundamental. Now talk of quality. Because concrete has to work for you for years to come, for decades to come, and it's not concrete alone, it is concrete and reinforcing steel. It's called RCC, as I said, reinforced cement concrete. Means, you know what is reinforcement in general, if you want to know. In general, when there is a war, there is a hot pursuit on borders, our armed forces go to fight with enemy. And when there is a shortage, there is a plateau, there is deficiency in the armed forces, people lose their lives. Then they call, send message, send reinforcement. Means there was a shortfall in the strength of army. They demand more army, and that more demand is called reinforcement. They say send reinforcement for 100 soldiers. That is called reinforcement. So in our world of this RCC, concrete is called reinforcement because there is a deficiency of tension requirement. Concrete cannot take tension and tensile forces or bending moments in negative or in tensile stresses. Steel reinforcing bars are used. This is basic requirement. If you understand this much, that is enough. If I go into further details that you may not understand, only engineers can understand. So my objective today is not for engineers but for general public. As far as concrete element, concrete technology is concerned, we call it concrete technology, not simply concrete because it is technology, because it has system, its properties speak, it requires something. This material says I need this, and you have to deliver that requirement. Otherwise there is nothing as such concrete. This shall convert to ordinary soil, ordinary plastic, nothing else. If you do not take care of this material at its manufacturing stage or its casting stage, you shall lose this forever. If you cannot fulfill, if you cannot provide whatever it needs, whatever concrete requires, you can never reclaim it. Then forever this material will be useless for you. Only few 2 weeks, 3 weeks are demanding years for concrete production here, production time. Otherwise this is nothing but dead. You cannot trust this material. It's like soil, that's all. Then understand why it's so risky. It's very significant to take care of concrete material at initial stages, at its production stage, or else your money goes waste, natural materials go waste, and you cannot reinforce, you cannot replenish those losses even in 100 years. Fire will impact your building, water will impact your building, Thermal stresses will impact your building and it may collapse any time. Howsoever higher diameter bars you have used, you may say I use this, but all is waste. As far as quality is concerned, life of building is concerned, you may think I have spent this much money, I have spent this much steel in this, and so much thick slab, but all have got no meaning because you did not put its soul, means its properties in concrete, and your money has gone waste. You are at loss. Even if you sell to someone, that person will bear same losses. I am just explaining this in blank language, in clear language, so that people can understand. Don't take it for granted. Your block work can be replaced, your brick work can be replaced, your plaster can be replaced, every finishing item can be replaced, false ceiling can be replaced, sanitary units can be replaced, water piping can be replaced, but concrete element is permanent. It is persistent. It is not transient. It's not temporary. It demands your attention. Though its cost may be lesser than cost of all other items, I may say, maybe it is 40% of all other costs, yet it bears all those services, all those finishes, all those decoratives on its shoulders. And if concrete is worst, your building is worst. And concrete is everywhere in building, in foundations, at ground and at all floors. Do not take building a toy. Do not consider it a toy. It's question of lifelong service. Your car will be thrown out after 10 years. Your TV can be thrown out after 5 or 10 years. Your mobile can be thrown out after 2 or 3 years. Everything can be discarded. But remember, concrete is reverse. As many years it attains more strength. After 1 year, it will get 20% more strength. After 2 years, maybe 25%. It goes on increasing and becomes more useful. So your money is getting indirect interest when you get good concrete. It's automatically getting fixed deposit if you do it, if you understand this. If you do not understand it, don't forget that today whatever you spend, your money will value it and you will get double amount of that after 7-8 years. In building it may be 3 times. It may be, you may say, today you spend 1 lakh, it may be 10 lakh after 3 years. It compounds. So your money doesn't go waste, but it goes completely waste if you don't care about this. Engineer must work as a professional doctor of engineering, professional consultant of engineering, and professional site engineer for engineering, for construction. It's no joke. It's not simply mixing and putting in. I have seen rubbish activities of formwork shuttering. They are using just certain steel fabricated planks, plates and standard one. There's no one to design. Design is missing. Forget that. Okay, there are engineers to design, but if you do not get it designed, only if you depend upon some illiterate builder, illiterate contractor and rely upon that person, or if you trust some mason or carpenter to get your building done, then you are wasting your money. I am not saying because I am an engineer. I am saying because it's your building. You are spending your whole life earning into this, and if you are throwing this money, throw it. It's your money. I am no one to say don't throw it. I have seen many buildings, balconies have been constructed with beams, and when it sags means it deflects means it comes down little, they put another structure below, another column or pillar they call it, they put that one. What is this nonsense? If same thing happens to your body, what do you think? If there's a defect in the body, should I put another hand there or leg there? Because you don't feel pain of building. That's why you are helpless, you are careless. And you want to save money, but you are not going to save money, you are going to lose money. It is very important to understand this point. It is question of your building whether it is good or it is bad. Do not worry about finishes and decoratives. That is another point. That is second stage. If your structure is not reliable, all your money you put on that is going to waste. Your plaster shall crack, your wall shall collapse and crack, and all your this decorative elements shall not work, shall not be. In beginning it will be fine, oh it's very excellent, I can see it looks very fine from distance, my relatives will come and appreciate, oh what beautification you have done. But only for 1 or 2 years. After that you will see thermal cracks there, you will see settlement cracks there, you will see motion cracks there, you will find so many distressful activities, automatic activities, self-formation activities there. And that is what you did for. You did for that. You have to raise question to yourself. Why did you not take this building as very important project for you? Why did you leave it to those non-professionals who do not know A, B, C, D of engineering? And why did you not seek consultancy from engineers? Why did you depend upon that professional who knows nothing of structure? Building a structure is not very easy to understand. Even sometimes well qualified engineers are confused because of calculations. Lot many calculations are done. Lot many, not one, not two. And many options are noted in, considered well. I should take this or I should take that. I should use 12 mm dia bar or I should 25 mm dia bar. I should go for this, I should go for that. What thickness should I consider in foundation and footing, and what size of column I should take? There are many ways to calculate. Many theories are available. 50 years back their working stress method was there, then limit state came, then different limit state methods have come now. And there are various codes which define many things. Those all points are considered by calculating direct forces, direct load, self-load, live loads. Live, I mean to say, when you are on a slab, when you stand, your load is there, that's called live load. Your articles are there, your goods are there, it's live load. And self-weight of your building is dead load. Self-load of foundation, self-load of column, self-load of beam, self-load of slab, linter, self-load all dead loads, forces. And live means which you apply something on that, and then wind force, that then seismic force or earthquake force, then thermal effect, then you can say fire impact. There are so many loads which are considered when we design some structure. That point public must understand. It's not simply you just raise anything and do. Each and every load is considered. Many probabilities are considered, many possibilities are considered. How balcony shall react when there is no load, how shall react when there is load. Both possibilities are there. In every case, different loading arrangements are done when we design, and it's not simply two-directional, it is three-dimensional. We understand, we solid. We say we are considering all directions, three-dimensional modeling, and we check that. So you are not aware of that, but it happens. Foundations are designed in a different way. We either consult or we conduct tests, soil tests, or we get information from records what type of soil it is. Without that taking into consideration, so you cannot go for design of foundation. If you do that, that's assumption only, that's imagination, that's just you are okay, it may be this much, I take this much. Because you think my building is very small, it's 2-story, 3-story, it's not color. Why you spend my money on that? Why should I spend money? Okay, you're right, you are constructing building for what? To die? You are constructing a house or a graveyard. What are you going to construct? These workers shall go away. This contractor shall go away. It is you who shall be responsible. It's not that contractor will go away. His job is only construction, not to take responsibility. Workers also not responsible. It's you responsible because it's your money. And if somebody dies, building collapses, it's your loss. You shall be in jail. That is only a reason I am trying to let you understand. This is my definition that concrete is very important factor. Concrete is very important factor. And do not use brickwork for loads, because our bricks are not to mark. Forget them. Use only structural concrete, and according to definitions of methods, there are no methods I have seen anywhere. Actually, services of engineering are not taken. People are not availing these services. That is a drawback. And that is the reason that engineers are not learning also, because they have no opportunity to learn. They are doing what was written 50 years back. They are just following that. Professors are following that. No one is having any research and initiative to produce more and more literature. If this happens, what to do? Why only in our country this happens? It doesn't happen in Gulf, it doesn't happen in Middle East, it doesn't happen everywhere else, only here. You may say you are just talking something bad for us. No, it's not bad for us, it's fact. It's fact. I talk to many engineers. Engineers having more than 20 years experience, 25 years experience, and I raise certain questions they cannot answer. And I am not blaming them as well, because they don't have any opportunity as such. Our buildings management virtually is in hands of architects, and I don't accept this. Because architect is not total professional for buildings. Yes, for space designs it's okay, for giving what sort of elevations it's fine, but to an extent structure engineering is concerned, only structural engineer or civil engineer who has good experience is only professional. And if you cannot understand this, what can I define? Can a dentist work on neurology? You can say orthopedic work on heart surgery? It's same thing here. Structural engineering is very difficult. Even in theory it is very difficult. And in theory if it is difficult, we have to think so much, we have to calculate so much despite we have softwares. Imagine that time when there was no software. It means software will give result, but that is software. It is engineer who is using that software. That engineer has to conclude what actually software says. That engineer has to decide, and that decision requires competency. That decision requires judgmental power. That engineer must have. And if you don't have that, you say, oh, I am MTech, I am PhD, I am expert. Person who thinks that that person is expert is nowhere, believe me. Everybody is expert to some extent. No one is perfect. What I think sometimes, my thinking contradicts that after some time. Now I am thinking something, for example, I decide something, maybe after 2 hours I rethink and say, oh no, I have to rethink it, there's something wrong in that, let me understand this. This happens. Or next morning I think, or after 2 days I think, when somebody talks to me. This means we have to deliberate on design by self or by someone else. Because we are going to produce this into physical shape that would work for decades to come. So we have to take some time and decision. I am not going to support to a promoter that I want this today. I am not your father's servant, get lost. I don't need your money. Let somebody else do it. You want it today. This work is going to be used for 50, 60, 70, 80 years, and you want it just in 5 minutes using thumb rules? I am very angry with those engineers who say, oh, we use thumb rules. There is no thumb rule in engineering, nowhere. Thumb rule, what is thumb rule? There is no thumb rule. You have to calculate it. If you can calculate it, run away from engineering. No need of engineers here. Thumb rule. What is no thumb rule? Yes, for architect may be thumb rule. For politicians there is thumb rule. For engineers there is no thumb rule. You have to calculate each design separately and then decide what you are going to do. You have to calculate quantities and see how to work on economical background, economical front. You have to see every issue. How shall it work on fire? How shall it work on earthquake? What do you mean thumb rule? Every soil is different. Winds are different, 160 kilometers sometime and 120 kilometers sometime. And earthquake areas are all different, all over the world. How can you say thumb rule? Means you just want to teach and you can say ditch yourself. You are teaching yourself something wrong and your junior shall learn something wrong and you are ditching yourself wrong. Your professor did not teach you all this. What sort of professor is he if you are accepting thumb rules? You can set certain parameters. That's different. You cannot say they are thumb rules because your parameters are based on particular area in particular region, and that's not thumb rule. That's local rule. Okay, for this area I have worked on 10 buildings. I have seen this is property of soil and this way I can move. In this area this is zone of earthquake and all that. That localization you can do for repetition of that area, but you cannot say this is thumb rule. There's no thumb rule. Concrete is different product. You are mixing something, you get this mix, and after 15 minutes you take another mix, both will be different. Because this is uniform, not uniform. When it comes from crusher, it's not uniform. In somewhere particle size 40 mm or more, 30 mm more, 25 mm more, in some percentage is different. If you do grading I am to say you analyze this by testing what size of particle, how many percent, what size of particle, how many percent, and you make a curve for stone aggregate, for sand or for dust and for, you just see that all are different. In both combined, you will find combined grading. This you may not understand, but generally it's for information that we have to work on that, and that's a part of trial mix. What is trial mix? That's the question then. What used to happen in past that we used to write in grade, this is 124 concrete, this is 136 concrete, this is 148 concrete, this is 112 concrete. Like that we used to classify grades of concrete. Yes, that's fine. But that was based on volumetric measurement. Volumetric, I mean to say, they used to consider one bag of cement which is 50 kilogram equal to 1.25 cubic feet. I am speaking cubic feet because if I speak in cubic meter, it is a very, very small quantity which you may not understand. So it is 1 cubic feet, 1 foot, 1 foot and 1.25 foot, a box, which means one bag of cement, and keeping unit of one bag we measure other items. 1, 1, 4, 1, 2, for example 1, 2, 4, one box of this one cement bag, and two of your dust or sand, coarse sand, and 4 of your stone aggregate. And there is water cement ratio, that is called how much is water in, when you mix one bag of cement. One bag of cement is 50 kilogram, say, then you say water cement ratio is 0.3. This means water quantity over cement quantity should be 0.3, means water should be 0.3 of quantity of cement. So 50 kilogram is cement and 0.3 is water, so 15 kilogram. If it's 0.4, it should be 20 kilogram. This way we move. 0.3 to 0.4 is generally kept when there is no water content either in sand or dust. We move like that and we see what should be minimum and what should be maximum. And then we have to see ratios. In volume we used to, but now volume system does not exist. It's not preferred. Weight system preferred. You have to see weight of different ingredients. So what are ingredients? Again, for information, is stone aggregate of 2 dimensions, 2 grades. One is 20 mm nominal size, which can be up to 25 mm, even 30 mm in some cases. For example, say 25% or 20% are around 30 mm, and remaining 20 mm and 12 mm in this 20 nominal size, and then 12 nominal size is the one. So there are 2 different types of aggregates used in mixing, and stone dust is there, or sand, coarse sand is there, of course water is there. So we have to design, that's called trial mix, for every grade of concrete. That should be done. Batching plant people do it or who do it, that's another issue. But trial mix should be done where you say weigh batching is called. Weigh batching, I have to say, by weight we have to mix these. So many kilogram of stone aggregate, 12 mm, so many, or mix up of both, and so many kilogram dust, or so many kilogram of water and cement. This is tested. Different gradings, different alternatives are done, and we reach that this mix can give that much grading of concrete. And before going further, I like to explain grading of concrete. That's very important for everybody. When we say grading of concrete, means they used to be M15, M20, M25, M30, M35, M40, and so on and so forth. When I say M, this indicates grade of mix, concrete mix. And say I say 25, for example. 25, it means it is in newtons, SIE units, standard international units. This is 25 Newton per millimeter square. And previously, if you see, it was MKS unit, metric units, metric system. It was in place of 25, it should be 250 kilogram per centimeter square. So that's difference only. Answer is same. This is compressive strength indicator. Means this mix should have that much compressive strength on 28 days of production of concrete. Means 25 Newton or 250 kilogram per centimeter square should be result after compression test. That is meaning of this grading. So when it is 15, 20, 25 different gradings, means that much strength this concrete should give when it is tested in compression on 28 days. It is tested on 27th day also, and that is about 68 to 70% on an average it should give on 7th day. That is only for purpose of ensuring that if we remove shuttering or farm work, it should not come down, member should not come down, slab particularly. This is grading. So generally M30, M35 should be used. M35, let's say, is better one for structural building, and if M40 and M45 and more go on where pre-stressing work is done. This high strength concrete we call that. So we have to understand first what is grading of concrete. So this is grading of concrete. Then there is steel reinforcement, that's a 415 Newton, or different types of steels are available. Tor steel means twisted bars, cold twisted bars, and hot, different types of bars are there. Those, whatever designs say, we have to use that. This is design element. And remember, this is very important point. If you don't understand this, you will not get that strength. And that comes only when you follow all technology, all procedures, all methods if you follow. Now point comes to site measurement. How to work on site. Site means wherever you are working on. After excavation is done, you can say soil testing is done, everything is done. You are going to start concrete. You are going to start your foundations according to your design, whatever design you got in. This means you have, first of all, ground you have to see it's good or not. Level have reached, everything you got, it say it's ready. I'm not going to do that detail because that's another chapter. I'm just talking of concrete element, which is very important for future. And don't forget that this, after all, against environment as well, because we are using earth materials, earth resources. So we are taking out, means by stone crushing, you are taking stones, you are cutting rocks, you are taking, you are excavating earth. In fact, you are disturbing natural earth balance, though it is to very minute one, but we are doing that. So we have to excavate, we have to reach that level, formation level it is called, level at which we have to lay foundation. According to drawing, that level is known as formation level, where we have to site our structure here. That level is called formation level. That level is very strong level. Whatever bearing capacity means, bearing capacity is that strength which our soil can resist. It may be 10 ton not kilogram, 20 ton not kilogram per square meter. If 1 meter and 1 meter this way, square of 1 meter can take that load successfully. It may be 10 tons per square meter, it may be 20 tons per square meter, whatever is considered by designer and soil investigator, that load is taken care of in designs. That is called safe bearing capacity. We call it SBC, or working bearing capacity. This strength this soil can resist, can transfer, because this load of building is to be transferred through soil to earth. That's what's called formation level, and that is bearing capacity of soil. If you understand this, this should be uniform all over your building, below your building everywhere. It should not vary. And you have to see soil there. If soil is bad, if it is clay, it is not friendly to your foundation. If it is graded, it is sandy or gravel, it's better, because there is a water movement in that. But in clay, it absorbs water. It is porous, it does not allow movement of water through its particles, through its pores. It retains them and swells. That's called porosity. Porosity of clay chikni mitti is very strong. It may be black cotton, it may be clay, whatever agricultural land, agricultural soil it is very dangerous for your building foundation. So try to avoid clay. Try to avoid black cotton. It's going to deteriorate your building. Or use raft foundation. Raft means to say complete concrete on that area, no separate footings or raft beams. Even then better you improve that soil. My suggestion is that remove strip of soil, clay soil, and put some granular material there, a mix of stone, big stones like 40 mm and voids filled with 20 mm, and then with dust, and level it like a thin road. Let's say 300 mm, 1 feet depth of road. You can say water-bound macadam below your building, so that that soil is removed, that bad soil is removed, and formation is granular. So water flow shall be continuous through that below building, and that will act like a filtering arrangement motion. Water shall not affect your foundation. Of course, it shall cost you some money, but it shall increase life of building foundation. That is called a kind of isolation between foundation of your building and soil below. If you can do this in soil of clay. I am talking about clay or black cotton. This soil is very dangerous. It is very good for agricultural land, not good for siting building, not good for foundations of building. This keep in your mind, and I am telling this to engineers also. Cotton, clay, is not desirable for buildings because it swells when it comes in contact with water, and it shrinks when water dries out. Means shrinkage cracks are there. Squeeze means you go to see fields, you'll find polygonal cracks there. That is because of draining or evaporation of water, and this goes on swelling when there's water in that. So in both cases, buildings shall either come down, sink, or rise unevenly, and that can be cause of concern from soil viewpoint. This is very specific point, because this can harm your building in totality. Where such thing happens, there is different bearing capacity at different location of a building below. Improve soil and use raft foundation connecting all columns below. Do not use different footings if soil bearing capacity is not good. If it is good, fine, you can use different isolated foundation. Yet I would suggest connect all by structural beams. And those beams should be deep enough, more than 1 meter, and maybe 30 centimeter width or 35 centimeter width, and you will find a mesh of beams on foundation, and these depths of beam can be used for underground water tank. You can store water there that can be used for fire or used for your tank on your roof. You have to think that way. You have to change your thinking mind. Do not repeat what was done in past. You have to think for future. And your owner, you have to think yourself. It's your building, it's not my building. I am just trying to help you. Engineer only tries to help you. Listen to engineer's advice. Do not go for blind architect's advice. I am openly saying this. Building means structure, nothing else. If structure is not reliable, your building is rubbish. It's a pool of graveyard, nothing else. That's up to you. You want decoration only? You want very beautiful finishes only? Or you have to live in that building safely? Only owner can decide. Forget all codes and acts. Who bothers about them if you are not happy? If you are not thinking of your building, no meaning of any law. If you are not decided here, every code, every law is useless for you. You forget that then. And if you decide here yourself, everything is there to support you. Engineer is a leader to support you. Yes, architect may design, okay, we will implement that design, forget after that. Forget architect after that. Soil, you have to take care of. Farm work, you have to take care of. Compaction of soil, you have to take care of. Concrete test, you have to take care of. Steel design, you have to take care of. So many care-offs are there. So when I said your excavation is over, your formation level has reached, you have to be strict. Surveyor shall tell you your formation level, he will give you complete level, or by excavator or by whatever method you are doing this, you have to level it and you have to compact it by using plate compactor or road loader as you do, whatever is accessible. Do not simply depend upon JVC. They will say, okay, I have done by bucket. No, that's not acceptable. Because when it moves on this surface, it disturbs also. Have you ever noticed JVC, when it works, it excavates, okay, excavation is fine, it disturbs natural level, natural formation. And when it does by bucket itself, that is not compaction. Its tire movement is also not compaction. You have to compact it once levels are reached. You have to remove all loose soil. And when you place additional material there, as I said, soil improvement, that also requires compaction. Problem is, compaction is not taken care of. People miss it. They do certain, sometimes this manual rammer they use, by then that the compaction is done. That is not compaction. Compaction means you have to solidify, you have to compact, you have to pack your soil. Soil which you disturbed, this natural formation you disturb by motion of excavator, bucket and tires. Whole soil was consolidated before because it was there for years. Maybe it was there for 50 years. You disturbed it. So your natural formation which was consolidated has been disturbed. So this is ordinary soil now. You have taken off your scrap and removed and transported all excavated soil. But natural ground is not available there. It is disturbed ground. You cannot put foundation on disturbed soil. This is illegal. This is not specified. This is not in engineering. This is nonsense. You are harming your building just because you are not compacting it. compact it. Compact it to a level until it does not rebound. And when it rebounds, you stop compacting. Rebound means what? You are compacting your leveled soil. You are moving it. And you, after water is spread, this dry and you move it, you compact it, and you think, oh, when I even compact, it's coming back again. So test them. Bring laboratory. Ask laboratory to come and test soil. See what is the strength. That is called field density test. FDD. Field dry density. You have to test that. This is a structural use. This soil is for structural use. And you must get 98% proctor density. It's called proctor density. If it is less than 98%, you cannot use for structural building on this. You have to bring that. 98% is a must. It can be more than 100 also. But 98% is a must. It depends upon of your soil sample that was taken before. So you have to do it on site, and if you are sure, laboratory reports say yes, this dry density is 98 and above, this means your compaction is acceptable. Otherwise you are in black world. I don't know, I did not do compaction, I just use rammer and started my blinding concrete on that. Blinding concrete means first concrete you do on that prepared soil, compacted soil, where your foundations have to be planted, sited. That is called formation soil, and concrete is called leveling concrete or blinding, or we call it blinding concrete in international language. Here people call lean concrete and somebody calls something, it doesn't matter what you call it. Question is, all uneven surfaces that have been created duly compacted must be placed by concrete up to level of foundation below. Where foundation base has to come up to that level, your blinding concrete requires to be done. That is original level where you have to go, you have to put your foundations on. This is called preparation work. This is called soil preparation as well as your concrete blinding. And if you want to apply some treatment for anti-termites, then before this concrete is done, you have to apply that, and immediately you have to cover with this. Well, that's one point. And now you have done it. This is low strength concrete. This is not very high strength concrete. Maybe I'm 25, maybe I'm 20. Then you have to cure 2, 3, and you have to start further. You have to start lay out for foundation, setting out sets for x-axis and y-axis, where columns are coming in, foundations, footings are coming. You have to do all that through surveyor. You'll get these points, and you do, on one end you are doing fabrication of steel for these foundations. Steel is also important here, because I have taken skill on steel. What is steel after all? What is steel? Have you thought of what it is? I said it's used for tension, fine tension, but tension is one point. There are so many other issues in that. This is carbon steel, this is ductile material, there are so many chemicals in this, there could be so many cracks in this. Steel means life of building in tension and in bond with concrete. Bond, when we say concrete, steel is here, this is concrete, this goes in like that. These both should be in marriage. This cannot be debonded. There is no bond, means if there is no bond, it comes out. And if they bond, it cannot come out. That's what is required. What happens? If you bring rusted steel or you bring good steel and put in, and moisture acts on that, rain acts on that, it's rusted. Rust means oxide. Rust means root for corrosion of steel. It will corrode it further. In 2-3 days rain, you will see reddish on this steel, red color on this steel. This means steel has been invited by corrosion. And you use that in your work. So you are speaking, hey my dear concrete, I am going to kill you by this rust, and use it. So what you think? It will work. You are using rusted steel in concrete, which is no meaning. First of all, there is rebonding, body will not work, and then still there is further corrode, and there is no connection between steel and concrete. So there is no concrete actually. This is soil, this is sand, nothing. So you have to think this way. You are spending money on reinforcing bars. I am calling it reinforcing balls because this is a real term, or you can say steel bars. You are spending so much money to bring it. According to your design, you are bringing it 12 mm, 10 mm dia, 12 mm dia, 25 mm dia, wherever you bring it. Bring it first of all in straight lengths. People are doing, they are bending this and bring it in trucks. What's meaning? This nonsense. You are first bending it. Half here you bend it, means you have already worked on that steel. At that point where bend appears in that curve, you have already worked on that, and steel is worked there. You will strengthen it again. It was straight, you bent it. Now your steel fixer will strengthen this. What does it mean? At that point there have been two works. Once you bent it, then you strengthen it, and then you are bringing it to that cut and use. This means you have already done work on that, at that portion, curved portion. You cannot understand this. Steel was for single work, not for 2 or 3 works. You have already used that strength. So remaining strength has gone maybe 20% reduction, 40% reduction, I don't know how much. So do not do this mistake. This is not technology, this is stupid action. You have brought very good steel, shining steel, strengthful steel. You have got catalog from company. This is your yield strength. This is length of this. This is tolerance of this. These are standard of ribs, and there's seal of that company. You are bringing. Go to bring by trailer. No problem. If trailer cannot bring smaller bars, but do not bend it. This is my suggestion. Rest up to you. If you want to spend your money, I can't help it. You have got this steel on your location. What you should do? You are not bringing 1 bar or 2 bar, you are bringing tons of steel. 2 bundle of 10 mm and 12 mm and this bundle and that bundle, all that you bring. 20 tons you brought, 10 tons you brought. Prepare some base on your site. Good platform by brick or by timber or by something, so that ground soil or ground water, or if there rainwater should not stagnate. There rain stagnant, your steel store should be above that. Stack it properly and cover with polythene, so that there should be no impact of moisture, there is no impact of rain on that, and cover it every day. Don't worry about expenditure on plastic. You have to do it if you want to save your money, and keep it clean. When you cut and bend, and if you are not using same day, cover that also. When you put on site, after day's work, cover that also. You have to do that if you want to give your concrete long life. Plastic is not very expensive, it is repeatable. It is on this you repeat it. Then you can use it on your building also, no problem. It's not very much turn off. You can roof or somewhere. You can use it when there's rain and you have done concrete, you can cover with that. There are so many ways you can use that plastic, and that's not waste of money. If you talk to steel fixer, they will laugh, because it happened with me when I was constructing my house in Faridabad. I just came from Abu Dhabi, and I was searching for certain steel fixers. I got straight bars from factory. I paid extra money for trailer, no problem, I'll pay. What's if I'm spending many lakhs on my material? I can spend few thousand on transportation also. Why should I worry about that? After all, I'm going to construct building. It's no kulcha chola or chai. It's building. I went to one steel fixer shop. I want this fabrication, I want your services. He told me, okay, I'll do this service at my price, fine. I asked him, how shall you protect my steel? Because I saw steel lying there and open, means just on soil they are keeping this. He told me, as you see, I do this, and no, I want production. I said, you have to cover my steel with plastic. He was laughing. Oh, how are you talking? Now I've done in my life. You can do it or you cannot do it, tell me. He said, no. I said, thank you very much. I did not do it. Khas, I don't need you. I stored that still on the area, put timber planks below, all stayed by I covered myself with polythene. And every time when this was used cotton band, I covered it. And when it was placed in a position, I used to cover. And when it was rusty also, due to some reason, I held one helper. Come on, take this steel brush and rub it. And that is not rub. Oh, I am not able to rub this. Why? I am paying. What's your problem? If you cannot care, what's the use of my steel? It's timber for me, not steel. This is what I am telling you. If you can laugh, laugh. No problem. I don't feel any degree of shame if you laugh. Because I am thinking for you. I am talking for you, not for me. Your house, your building. If you laugh, laugh. Okay? So what I am saying, when you have done foundation formwork, I mean to say better use your marine ply. Do not use standard plates which these people are renting. If you have a repetition of 5 or 4 times, you have to calculate, or your engineer will calculate for you, or you are somebody who knows how many square meter of your shuttering or formwork is, and you can use 4 times or 5 times. Best is 4 times. This red color ply or marine ply, we call it generally, it is water resistant. If you buy that, that's best for you. Because you have to see how many footings you have to do, how many repetitions can be done for beams and for columns, how many repetitions can be done for a slab, how many, because you may be having 2 or 3 or 4 stories. So you can see if repetitions are done, you will use that plywood perfectly. You can buy timber battens and you can fabricate these formworks. You may have some technical person with you. You can fabricate and put according to the site requirement, and fabricate steel according to design and place on site. Fabricate column also. First go of column means column below ground and little above. All those you can do, but do correct. Use concrete spacers, we call it concrete covers. Small size biscuit type, 50 mm cover, thickness 50 mm, thickness 40 mm, thickness 30 mm, thickness 20 mm, depending upon what elements you are going to cast. If its foundation is going to be 50 mm, its column it will be 30 mm, its beam it is maybe 30 mm, column 40 mm, sorry, column 40 mm, I mean to say 4 centimeter. In columns 40 mm, in beams 30 mm, in slab 20 mm. These are standard one when this normal fireproof or it's not near seashore. Near seashore we can little enhance or increase these. For if you have 2 hours fire resistance, we can increase these. It depends upon where this is, and this should be perfect. You put binding wires in those concrete. Better avoid plastic spacers because these are not very good for foundations and for strength. If you can cast on site by making a frame of that and putting concrete with gravel size, small size, 10 mm jeera they call it, and put biscuits called, maybe hundreds you can produce in one frame, and put wire on that. That's best one with same grade of concrete you are going to use. These are called concrete covers or concrete spacers, we call them, and you can have different sizes according to your cover, 30 mm, 40 mm, 50 mm, 12 mm, like 20 mm that, not less than 20 mm. Because in slab below it should be 20 mm, that is required. You can do this many days before you start work because setting will take time. You can fill them in drums or whatever system you have, and you can store them in water so that they keep on getting strength further and further. So you have your blinding concrete ready, you have your column alignment ready, you have placed steel frame there, fabricated steel, and you have placed both ways or whatever design and erect your steel of columns and which supports you have it. Then you have to cast concrete in that. When it is ready, you have to ensure that your shuttering shall not come out during pouring of concrete. And remember, before this work of RCC or placing steel, you have to make sure that you have done waterproofing. That you have to make sure before doing this formwork, and I'm calling it waterproofing. Actually, it is not waterproofing. Member layer that you place, that is waterproofing. Bituminous membrane or whatever you apply there, it's waterproofing, but function is not actually waterproofing alone. Function is different. Generally, we call it waterproofing, horizontal surfaces as well as vertical surfaces, or it may be whole raft, means all you have to waterproof. They say waterproofing. Okay, speak waterproofing, but remember, it's not waterproofing. This is misleading term. It may be partly waterproofing, but purpose is different. Every soil contains chemicals, contains salts, contains sulfates, and there's alkalis, and there are so many other. Water movement is there among soil. Water mobility in soil mechanics, we say water moves in soil from this place to that place and that place to this place, because if soil is not everywhere clay, there is a pore to pore movement, and that is called permeability of soil. Means water moves from one pore to another pore to another pore to another pore, like that. This means chemicals move from one place to another place. Water is not pure, it's chemically full. And then soil particles may also be that. And that can impact your soil, your foundation base, your foundation sides, your column that is within soil, that one. This can impact adversely your foundation concrete. To protect that member from this chemical impact, chemical attack, we provide this so-called waterproofing membrane. Horizontally as well as vertically, every surface in contact with soil from below and from sides must be protected by this membrane, so that your concrete is safe from impact of chemicals from soil. It is called soil protection, I mean to say concrete protection from soil impact, or you may call it waterproofing protection. It's up to you. This term doesn't make a difference, but you have to do that. And on that, you have to do your foundation work, as I told. If there's a beam, do beam also at foundation level. It depends upon design. And when you are ready with all this, you have provided concrete covers and everything, and if some service is there, say, I'm not sure, if some service is there, for example, services of drainage or service of some water coming from top, rainwater, if it is there, you have to coordinate, you have to talk to your plumber or your other guys. And when you are ready with that, you say that my work is ready, you have fixed levels of top of foundation, then you can get it approved if it's your procedure. If there is no approval, your approving authority, I have not to say anything else. And here's a contractor, no, you have to get approval of consultant or approval of engineer. That is procedure. You do that. Then you have to calculate quantity of how much you want to pour. Say you are going to cast 10 footings or 5 footings or 50 footings or 20 footings, whatever is there. You have to calculate quantity of ready mix, because ready mix is common these days. You cannot do that much by site mixing. Ready mix is very common, but that ready mix should be professional. Remember, do not believe in what ready mix person says. They may say so many things. This is Bharat, India. I do not believe anybody. Go and see, take your engineer there and let him see what they work, how they work. Are they professional batching plant, or they are just batching plant for sale? There should be silos, there should be calibration of mixer, electronic, there should be ice plant, there should be combination of cement. For example, this ordinary Portland cement and to be replaced by GGBS or by pulverized fuel S. Everything should be there. and it should be third party certified, all calibrations, everything. There should be chemical element, how to fix chemical, how to do, and they should test it. Whatever production of, they should follow your trial mix. They have to set their calibrations according to your trial mix parameters. They have to set all those batching plant calibration dials accordingly, and then they produce concrete according to that and take samples by slump test, by other air voids and all that, and cubes also. If slump is fine, they should allow transmit. This will give a dock. This time this truck is living. This is its value of slump. Whatever information is available, you understand that and let this come. And at site, you have to take slump again. There is tolerance in slump. There is a definition of slump that it should give that much or not this much. That should be within that limit. You are using crane, tower crane, maybe you are using mobile crane possibly, or you are using concrete pump. That generally happens. These are mobile pumps are available, and also reciprocating stationary pumps are available. Both can be used. You have to ensure that slump is within that limit. It may be 50 mm for ordinary road work. It may be 75 mm for crane if it's building work. It can be 100 mm depending upon what design was agreed for. And that slump test must give you within that tolerance limit. If it is more than that tolerance limits, you should not accept that concrete until it comes to that level, because it's question of workability as well as durability of your mix in future. And if slump is fine, you have to ensure temperature of concrete. That is very important, uninformed to our people. Temperature of concrete and temperature of weather both, these points are very significant. If temperature is less than 5 or 4 degree and more than 32 degrees Celsius of concrete, do not allow concrete. Do not allow concrete in that case. In normal situation, if it is 45 degrees, 42 degrees, 40 degrees, do not do concrete until it is very urgent, in which case you have to add ice to concrete mix so that this temperature is maintained, or else you are doing mistake. Remember, in that case, if you cannot control this, better do concrete either early morning hours or late night hours when temperature comes in that range. This is generally, you must have seen where concrete rig is done either done at night or at early morning, depending upon how your batching plant, your central mixing plant can serve you. We have to be very serious on this account. No sympathy, no emotions. This is after all concrete. Destiny for someone. You have to define, you have to instruct batching plant person at what frequency you want delivery. One truck may bring 9 cubic meter wet concrete, or 6 cubic meter wet concrete, or 8 cubic meter, depending upon capacity of that transit mixer. You have to see how fast can you place your concrete depending upon how many concrete pumps you have. You may be having one concrete pump, you may be having 2 pumps, it depends. And how many concrete vibrators do you have? How many? Maybe 2, maybe 3. And remember, vibrator should be standby. If it is compressor one or it's electrical one, it depends, but you should not wait for vibrator. That is broken, I cannot do it. No, that's not way. You have to stand by this. And also you have to tell batching plant, you have to keep standby one mixer, because always there are 4 mixers or 3 mixers on every batching plant. They usually work in 1 or 2 at one time and remaining are standby. Because in case one is broken, other should come into action. Because concrete cannot be stopped until it's impossible. It cannot be stopped. Once it starts, this is law of concrete. Once you start, you have to finish your target and you have to be ready for that. Because if it is broken, there is no way to repair it. There is no way to replenish loss, or there is no way to reinforce it, as I said. So consider it like a process of any plant. It's a process for that concrete element which you are going to pour. Once it starts, you have to define its timings. How many hours would it take? How many mixers or transit mixers load would come? What slump is required? What is frequency between one transit mixer and other one? How many minutes would it take for vacating that mixer, and where that mixer shall wash and dispose this concrete liquid, residual liquid, and which place it is. All that you must make into your mind and do accordingly. All mixers must come accordingly, and your crew should be ready to accept that once slump is clear and temperature is within limit, and pour it. And remember, pour cannot be done in full. If your thickness is more, do not pour more than needle thickness, needle length, because you have to vibrate every layer. If you do not vibrate, vibration means compaction. Making loose concrete achieve its density, which is 2400 to 2500 kilogram per cubic meter. 1 meter, 1 meter and 1 meter and 1 meter. It is 2400 to 2500 kilogram per cubic meter. That must be attained. And how shall you know it is attained or not attained? For that we have to take cubes of 6 inches by 6 or 150 mm by 150 mm and by 150 mm cube. 6 number of cube you have to take for every sample. These cubes shall be taken once slump is okay, when temperature is okay, and once your air voids are okay. Your technician shall take these cubes in your batching plant as well as on site, and these would be tested on 7th and 28th day, and strength shall be monitored. So if cubes are okay in density and strength, your concrete must be same. That is an understanding. These cubes are placed in water for so many number of days, or can also be kept on site conditions. That is decision of engineer and yours own. For me, both are same. In site laboratory conditions, these shall give little higher strength, while on site it may not have that much strength, little difference. But site condition is practical condition, though our codes do not mandate, international codes do not mandate, do not force, but it depends. So if your concrete cubes give correct results, acceptable strength and density and standard deviation limits, your concrete on site is understood to be same. You have to pour concrete into your foundation, every foundation, and vibrate it, and you have to move accordingly. There may be beams or there may be footings, whatever it is. If it's more than 40 centimeter or 400 mm, you have to do it in layers, put layers, vibrate it, then come back and do it again, because you cannot delay it too much. Remember, if you delay it by more than 30 minutes, it's a problem of cold joint formation. Cold joint means old place concrete and immediately new place concrete Both should be monolithic. If it's already set, it's cold, it's not hot because temperature has gone down. When it was 25 degrees, 30 degrees, 32 degrees, 35 degrees, it was hot. And other concrete has come now, and this has taken 1 hour. So this is now maybe 20 degrees, maybe 15 degrees, other one is 30 degrees. So this is called cold concrete with hot concrete, and this is not acceptable. Both should be hot. That is called cold joint. Cold joint must be prevented, must not be allowed. And also, this is cold joint I am talking, which is not acceptable. Then there is flash setting. Flash setting. What is flash setting? First you have to understand this also as common citizen. Temperature of weather. Let us say it is 35 degrees. It is 40 degrees in some cases. Steel is hot. If you touch steel, you will be, oh, it's very hot. Steel is hot. And you are putting concrete having 20 degrees temperature on that. 20 or 40 degree, what shall be the result, you know? It's a flash. There's a dispute between between steel surface and concrete. This is called flash setting. Means concrete shall be set on that hot steel, hot surface of steel. This cannot be permitted. Hot surface of steel bar and lesser hot, much lesser hot concrete, both are in contact. High temperature of steel surface shall impact this concrete. Green concrete or wet fluid concrete. This is called flash setting. This is not permitted. The solution is, before starting concrete pour, just cool it by spraying water on that steel. In just putting water for 1 minute or 10 seconds, it will not rust because concrete is after all coming on that. So just reduce temperature. Let it be on shutters, let it be also steel should be kept cold. So temperature are not much different. So cold setting is okay, it's permitted. Flash setting is not permitted. So two properties. One is vibration and avoiding cold joint between two concretes. First is vibration. When you vibrate second layer or another layer on previous layer, your needle must go into interlocking arrangement of old layer. This is layer, I must say this must go like this in old one, so that interlock is there between two layers. And flash setting we have to avoid and move, then no problem, move all over. And if it's too much deep concrete, let us say it's a big foundation of 1 meter, 2 meter deep concrete, and it's a mass one, for example machine foundation, very big one, very big compressor is there, say 25 meter length and 10 meter width foundation with 1.5 or 2 meter depth. In that we have to design stepping, means this concrete should be done in stepping mode. One layer in small layer, then another layer, then one layer on that side, then in step mode it should move. To consider, because there also we consider cold joint, we also consider flash setting, everything is considered there. Same thing is building foundation, you have to consider. Means concrete method statement of pouring must be there before starting your concreting pour activity. You shall not find this in professional books. You shall not find this in professor textbooks. You have to use your mind and do it. Conditions are there, requirement is there, criteria is there, flash setting criteria is there, cold joint criteria is there, slump criteria is there, temperature criteria is there, frequency of transmission mixer process, every criteria is defined. Then you have to think of. You are engineer, You are owner, you are spending money. Engineer is to check this, control this, where is dispute. And if you are not hiring engineer, this is your fault. Don't hire. Let your money go to waste. What can I do? I am just talking in interest of your money, in interest of structure, in interest of its use in future, in interest of those occupiers who would use this building. It is in public interest, it is in national interest, it is in international interest, because you are using natural material. You are not using a spare part from some factory. You are using natural material. So you have to use this natural material in best possible manner. If you cannot use that, there is no meaning at all. So you are going in a way, professional way. It's more than surgery. It's more than surgery, because concrete which you have produced is not dead element. It is of course dead weight, but live weight is also there. Live force, live action, seismic action, earthquake action, wind action, thermal action, water action. So many actions are there. Earthquake can damage it internally. If it settles by soil problems, it can affect vertically as well as horizontally. You have to understand that point. If concrete is not very homogeneous, it cannot act as unit. And your whole foundation must act as a unit. Like a stool, you have your homes, you see from bottom portion of stool is tied up. You have a desk, a table of timber or something, it cannot do this way. It cannot fail, though it vibrates, but it cannot fail. Your building is accepted if it vibrates to certain limits. That is acceptable from a structural viewpoint, because it releases energy, distributes energy without impacting on structure, but it should not fail. When you stand on the railway bridge and train passes below, you will find your bridge is vibrating. But when train passes away, your bridge comes back to stationary position. Same application is on building. And when foundation is susceptible to that, it will pass vibrations to upper structures or superstructures. So I said concrete this way, complete all concrete this way. And you say, I have done it. You have done timber floating on that, and it starts little, you can say, little solidification. If you have curing compound, do you know what is curing compound? This is a chemical that can be used immediately on concrete, immediately after surfacing is done, to spray on that curing compound, so that it can form a uniform layer on that surface, which is exposed one, and can protect it from being evaporated. That is curing compound application. If you have, you can get it from manufacturer who are construction chemical dealers. There are two types of curing compounds. One is water based and one is wax based. Both are there. If you use water based, it's up to you. If you use wax based, it's up to you, because it is foundation ultimately. Wax based is more efficient, water based is less efficient, but it is efficient to protect your concrete from immediate cracks. And you can save water if it works well. And if you don't have curing compound, okay, you say it's too expensive, it's up to you. You can just, when concrete is well formed and little set, immediately cover it with polythene sheet. Don't wait, no need of wait. Cover with polythene sheet so that evaporation of water from concrete remains within concrete. And when after 1 hour, after 2 hours, when you see concrete is over everywhere, and it can take your water filled Hessian bags or saturated Hessian bags, water saturated, you can remove that polythene and spread your saturated Hessian bags or gunny bags and cover with polythene again. Cover with polythene again. Don't worry about wind, you can put some stones on that so that this polythene doesn't blow out or fly, and you have to keep that portion watered in all time until 7 days, 8 days or whatever period is allowed according to your specifications. This is called curing of concrete, immediate curing of concrete and later curing. And when you open sides after 48 hours, your foundation vertical sides, you have to apply that procedure on this also. On vertical sides, same saturated bags and polythene cover. And also that exposed portion of this column in soil, that is called stub column in our language. That starter steel bars means from foundation projecting up to ground and above or plinth level, that is called stub column. Those steel must be wrapped in polythene all. This is called foundation concrete. Do not be happy that you have done a lot. You have done only one activity. After that, what you should do? This is concreting one. Testing of concrete cubes shall follow up. That is another principle. Another procedure means you have to take out cubes next day from your steel molds, cast iron molds, whatever molds you have. Put them in either on site or in tank, water tank. Or the laboratory guy comes, he does it, or if you have some expert on that, you can do that. Keep them in water, in tank, water tank, or if agreed available to keep on site, you can keep on site conditions also. But this must be cured where you are curing your concrete. This is very important, remember. So, I am talking of foundation. Concrete is done. 48 hours are, depending upon temperature of weather, 24 to 48 hours are enough for vertical surfaces to be removed. Means shuttering to be taken out, or formwork to be taken out. You have taken out that now. You have to see surfaces how these are. These are okay or you need further repair. If these are okay, fine. If you have curing component, apply that on that, and if you don't have, cure accordingly. So your foundations are done. Then you have to start stub columns. In polythene, you have to remove those polythenes and shutter them. Shutter them. I mean to provide shutters on that by surveying all positions of these columns, and steel is already there. If you want some electrical conduits which according to design coming, you can put them also. You can put electrical pipes, conduits, and some thermocol or some polystyrene where switch panel is coming, if it is within concrete. Measure it, takes to a support well, and if bolts are required in columns, provide tie bolts. And column, stub column is very small quantity. You may not get pump for that, no problem, but ready mix we can get for that. You can cast this slowly, gradually in layers and vibrate. So your foundation concrete is over once you pour these concrete columns. This is your foundation structure, simple one. Your stub columns means small columns, and your footings are over. But technically you have to care for everything, same as I did before. You have to take care of slump, you have to take care of everything. Then you have taken out your shutters after 24 to 48 hours of these columns and use curing compound or cure them. Now you have to clear your site from foundation because your structure is over. Your structure, if there is some block work required according to design on that foundation to do this, bring that level up to your plinth level or ground level, which level you have. Clear it. Now you have to use backfill. Remember, backfill, what is backfill? You have to fill that portion around footings which was excavated and is to be filled back. If you have good soil from your site, I am not sure. You test it if it's good for backfill or not good for backfill. And if you have to import from some other source, you import it before test is done. Test it if it is good, or they would advise you that you add into this soil some other material, for example some sand or some dune sand or some other graded material or stones of different sizes. You have to mix and it is graded fill. Why they would say? Because your building is going to take a structure, so that structure should be like that. So you have to test this soil in laboratory and then you have to use it as per their suggestion. They say no, you add this material into this. Meanwhile, you have to apply waterproofing, so-called waterproofing on those all concrete surfaces, footings and stuck columns. You have to apply that soil protection membrane or waterproofing membrane onto that, and once you apply that membrane, you have to protect that membrane also, because that membrane is very flexible. It can be punctured. So you have to protect this membrane from impact of backfill, because backfill also got stones in this, less than 75 mm stone or further. This can impact puncture your membrane. So there are two ways: either use some board around or use some block work or brickwork, whatever is given in your details. If it's not given, you can do block work around this wherever this is coming. And on horizontal surfaces, you have to apply some mortar-like situation. Means where there is horizontal for foundation top, you can apply 25 mm cement mortar in horizontal surface, and on vertical surface you can apply this border or some plywood or brickwork or block work according to detail. Means below your ground, this must be protected. Otherwise you cannot backfill. Once it is protected, all whatever is there, I mean to say footings or plinth beams or whatever is there, you have to protect that. Wherever water proofing or soil protective membrane has been applied, that requires protection. Otherwise it has got no meaning. After that you have to start clearing your site and backfill has to be started. And remember, backfill is a structural element. It is a structural fill. It's not just fill. It has to be in same pattern as your backfill engineer, your technician of laboratory advised you. You prepare that one and start filling in layers. You have to take out all particles below foundations and sides of foundation pit. You have to take out, clear it and start backfilling in 20 mm layers. Not more than that. 20 mm layer is to be filled loose, and that has to come back to 150 mm layer. After compaction, you have to use plate compactor to compact this. This plate compactor is available. It gives 1 ton per square meter. You have to move it many times. Water it and move it, dry it, move it. And you have to take field density test. Field dry density test, so called FDD. And again 98%, because it is structural fill. Well, it depends upon, but you have to fill layers. Don't just bring your JVC and for no, that's not acceptable. Yes, you can take help of JVC or the excavator for purpose of accumulating, but you have to spread in layers. What I have seen, nobody knows this. They just put in carefully and do like this, and that's done. No, that is not acceptable in engineering construction. You have to be very specific. You cannot sleep. You have to keep your eyes open, your mind open as an engineer, and also more open as owner. Yeah, maybe engineer sleep, you don't sleep. It's your money, it's your building. It has resale value. Compaction must be done in layers. No question, no. Even if it is 1 meter deep, it is 1.5 meter deep, whatever is that, it has to be compacted in layers. We call it courses. Each course to be tested until it comes to below grade slab level, where your plate compactor cannot reach in certain corners. You have to bring another equipment for that and compact. Compaction is very important, and remember, before starting compaction of layers, your sanitary pipes must be there, underground sanitary pipes, underground electrical conduits, or whatever service is there, whatever is there must be laid before filling is done, backfilling is done. And if it takes time, certainly, you cannot say it can be done in 1 hour, it takes time. There may be in 2 meters, you can say 15-20 layers. So you have to do that, it takes time. And then you are reaching at grade slab or ground slab. Foundation work takes time. Remember, if there have been underground water tank, that also you have to do before doing your foundations. In case there is fire water tank, you have to do that also. Sometimes what we do, we have deep foundations and we use rather in place of footings, we can use beams. Big beams means deep beams all around, connecting all columns, which I did at my house. I connected all columns with these beams. There was no spread footing, no separate footing. These beams acted as footing, and I put one tank below, bigger beams are also there. Just make a structural tank and fill with water so that it can act as water supplier, reservoir, as well as fire tank. It depends upon your design, how you design, and you make use of that. So this is your foundation work. You have come up to below ground slab. Below ground slab means backfill is there. You have to ensure that backfill is leveled, and you have to apply your, if there is termite treatment, something, if it is there, that is another issue. You can all do all that. Then you blind it whole area. After your piping is done, whatever piping is there, blind whole area. Blind means lean concrete that area and keep it ready for ground slab. There will be polythene sheet that's required on that. Then prefabricated steel mesh, which is generally called BRC, because there's a company, but it's not necessary your BRC. Prefabricated mesh of 8 mm or 10 mm. It is designed, is designated as such. Whatever you are going to use that, make that on ready. Your sides are already there. There should be a gap between your structural member and this slab. This slab should act as floating slab, and just concrete that accordingly. Maybe 15 centimeter thick, around 15 centimeter, it's acceptable. If it is residential area or commercial area, if it's a machine or something, that is different. For that you have to construct machine foundation also before doing this ground slab. So ground slab is done as an ordinary slab, and your ground or plinth level has come up. Now your structure of super body will start. Superstructure starts. So what you have seen up to now, what you have gone through up to now in foundations, that excavation has gone. Excavation to defined areas have come. You excavated to that level. You can say dressed up that level. You compacted that level. You have taken field density test at that level. Then you have applied treatments, whatever chemical treatment, something, and you blinded that one, formation concrete, and after that you waterproof that surface and install your shutterings, formworks and steel and concrete that. Here you have to be sure of dimensions and sizes of footings and columns and locations as shown in drawing. And then you concreted your footings and prepared for your stubs and did your concrete stubs and all beams whatsoever, and backfilling after protection of waterproof. So this is what you learned. You have learned concrete here, footing concrete, stub concretes, waterproofing, backfilling and grade slab. This is called foundation element. Foundation element, this is of course time consuming and reliable. If this element doesn't work, whatever you do on superstructure is useless, is baseless. So we have to be very specific up to this level. This is complete engineering technology where design was used, where rock mechanics or soil mechanics was used, where construction technology of concrete was used, where formwork standards were used, reinforcement, cutting, bending and everything is used. All these were used up to this level. This means this is also called substructure, we say it. You may call it foundation, you may call whatever you can. So you have reached up to your base. You have a base now on which you can start your superstructure. I call it superstructure. You may call anything. Technical word is superstructure. That was substructure. Foundations and substructures. Because part of column is there and foundation beams are there. Foundation footings are there. All are part of structure. You may have 20-story building, you may have 10-story building, whatever number of stories, that doesn't make a difference in this talk. It can be anything. Question is how to mold yourself to quality methods. Actually, this is a method I am talking to you verbally. This should be in writing. Every activity should be defined in writing. But here I am just talking to you so that our culture has changed. People are not interested to read anything. People have become laymen. They just want to listen. If they are thankful, they are very nice, they listen. Otherwise, they do not even listen. So what should I do? Either writing takes a lot of time, and if people don't read, my writing goes waste. It is only in Facebook or somewhere else and dumped in. Who bothers? If you listen, you bother. Anyway, however, it is your choice. My duty is just to advise you. If you don't take advice, thank you very much. I have no problem. So this was actually verbatim of a statement so that you can understand what I am talking and what's happening, how I am telling. This is a kind of method statement, normal statement. This is not research statement. This is not design statement. This is just activities and activities link statement. So your testing would be done, everything would happen. You may not be sure the test failed, how my foundation failed. Yes, if your test fails, your foundation fails successfully. You have to reject it. But remember, First test is conducted on 7th day of 4. So by this time your foundation 7 days test has been done, concrete test. Your columns, sub-columns test has been done. So you must be having information from test whether it was fine or it was not fine. And 28 test is last answer. So meanwhile, if you think there is a problem, tests have failed, then you are standing on a fire. Generally it doesn't happen when you get concrete from professional batching plants or central mixing plants. Generally this doesn't happen, provided you have done concrete according to specification requirements. If you have done curing, generally you will not find failure of your test results, cube results. Generally, until curing is not done. Even curing on cubes is not done. Forget about site. Even curing of cubes is not done due to some lapse, then it's a big problem. In that case, if cubes fail, you have to take out cores from your concrete on site, cast on site, and that cores shall be tested, but which is very long process and that's very difficult. So better take care of supervision at every step to save your work, to give life to your work. Now I am going to enter superstructural world. It depends upon your design, what sort of building it is, what sort of structure it is. There are two ways. One is complete cast in situ, means all building frame or whatever height you are going to cast on site. And there's another way to just fabricate, just precast slab panels in factory and cast columns and beams on which these panels would rest on site. So partly cast in site and partly cast in factory. Two ways are there. First I am going to talk about cast on site because that is very common. Factory is not applicable directly in ordinary houses because it creates another issues. So we talked layman type, whole construction activity goes on site. Activities are same, but you need calculations. You have to make sure about quantities of plywood, quantity of timber battens or wooden battens, quantity of vertical props or scaffolding to support this slab or staircase west or whatever structure, wall or something else is there, beams are there. You must have details of all these, square meter details, and how many columns are there in one floor, how many you want to cast one time. It is up to you to decide. Already overlap is available from stub columns. You did columns in foundation, stub columns, overlap is there on which you can place your steel. You have details of steel reinforcement and you can cut and bend and fabricate and provide that column steel on every overlap of column. That is very plain, means you have complete details, you have bar bending schedule, you cut and fabricate, but protection is needed, again I am saying. So you can fix your columns and you have to fix full height of 1 story and maybe above. If you have steel, if you have 3-story, 4-story building, you can place hole, no problem. And if you can manage, remember, if you cannot manage, then cut in halves and one story you put at. It's up to your management. Vertical columns are fixed. but it's nothing, because you have still question is casting, question is concrete. You must be clear about thorough information. If you are not clear about thorough information, you can make mistakes. Bars, overlap, you have to be sure how much you left. And if it is 25 mm bar, if it's more than that or more than 20 mm, and I would suggest even for 20 mm, do not go for overlap. Overlap may work up to 16 mm, 12 mm, okay, but more than that, it's not desirable, it's not suggested. You should avoid higher dia steel size in buildings. If you can, you ask your designer that I want to use 16 mm or 12 mm bars, which is much convenient to use, much convenient to handle. Try to maximize 16 mm. 12 mm is best one, because lesser size of dia means proportionally its circumference is more. You know what is circumference? Outer distance of outer surface length, it is called circumference. So circumference is more in lower diameter bar. This means bonding surface area is more. Higher dia bars don't have more in comparison to lower one. So if you are forced to use 20 mm above due to whatever reason, better avoid overlaps. Get couplers available, mechanical couplers available, and use them. Before using them, test them. Mechanical coupler, do you know what I am talking? I am talking of these two bars and a kind of union arrangement here, these bars here, a kind of mechanical connection between two, that is called mechanical connectors rather than overlapping. That's the reason I'm telling avoid using higher bars. Use maximum up to 16 mm. If required, you can increase size of column in your design before delivering design to site, so that same thing comes up from your foundations. And if you increase diameter, size of your column, it will be better for you, rather than squeezing size and making it slender, because 30 or 300 mm is minimum dimension required for a column, not less than that. That dimension and height of column and that dimension of 300 cannot exceed 12 in normal way. If it exceeds 12, don't use it. For example, I have seen people are using, you say 9 inches, or you got 22 centimeter, 220 mm. 220 mm, and you can say this way, 350 mm or 3000 mm, it's more than 12. This is not short column. Actually, this is not a column, because minimum dimension should be 300 mm. So it cannot be called a load bearing column. So simple. Do not be dismayed, do not be swayed by these contractors or so-called builders, because they always mislead owners. And they talk in a way you think he is Satyavadi Harish Chandra. You think that way. Your concrete is very important element. It's leg of your building, it's shoulder of your building, it's head of your building. And if you cannot understand this, I cannot help it. So, steel reinforcement is very important, remember. Its cutting should be according to your design, your schedule, and then your installation should be according to standards and drawings. So you started ground floor from zero level to your first floor level. Whatever you had done, you installed that. All stereo installed. You have prepared your system on which you work, means some kind of scaffolding system on which you can stand by using some plywood and work on that to fix your steel. And then you have to think of your formwork. Formwork is column formwork as well as your suspended arrangement formwork. Column formwork better take full height up to beam bottom level. Do not go 1 meter, 1 meter. This is a stupidity. In this age of 2020, you are using 1 meter, 1 meter, 1 meter or 1.2 meter, 1.2 meter. Are you stupid nation? You cannot cast your column in one go. How can you maintain quality? You cannot maintain quality, you cannot maintain workmanship, you cannot maintain anything in this. Take full height. That's why I am saying increase size of column. Keep 300 minimum, maybe take 450 this way or 500, 600 this way, depending upon design. Your span may be 5 meter, column to column. It may be 6 meter. It depends upon how you are designing. So take comfortable use of column shuttering, because beam is lighter than column. Remember, column is considered stronger, and where there is seismic force, where there is earthquake actions, always column is strong. Strong column is theory. Beam should be lighter than column, because column is vertical member, but during earthquake forces are acting, they act horizontally, so that can resist your forces, earthquake forces. That's why column should be heavier, stronger than beam. So your column should be so comfortable in its concreting that your vibrator can come down even to lowest point of your formwork. That is very, very significant. If you can do that by increasing size of column, you can comfortably use 12 mm rebars or maximum 16 mm rebars for distributing your steel reinforcement in column section. Not necessary to say keep at one point all these bars, spread them. Spreading shall give you many benefits. Means spreading your bars on skin surface of your column. Spreading your bars so that first, structurally it's okay. Secondly, we can cast whole height of column. Thirdly, this skin many bars will protect from cracking, will protect localized stressing, and horizontal distance between two bars can be used for purpose of calculating bending moment at that point. Bending moment which comes in column, which is important factor, because bending moment is force applied on column, and this gap, this distance between two bars would provide moment of resistance. Bending moment and moment of resistance are two terms. Example, I'm just telling, there's a beam, say I have a beam here, there's a load on beam, this beam tries to come down. This beam tries to come down, I mean to sag, though it is not, cannot see sagging, but it tries. But we have already provided concrete depth and steel in that, so it doesn't sag. That force, that action which tries to bend it. That is known as bending moment. And this force within this beam and steel which is stopping from coming down or bending, that is called moment of resistance. Means resistance and force. This is what I am talking about. That is applicable in column as well as in beam, and that is also applicable in foundation. So you try to cast full 3.5 meter height or 4 meter height in one go if your vibrator can reach below at bottom level of column. I prefer that one. That is professional one, because you are not wasting time, but your form work should be professional. Form work of column should be professional. You have to take services of form work company, form work people. If you don't have your own engineers, they can devise you, and you can use ply also, timber batten also to fabricate on your location. 12 mm ply or 18 mm ply. 18 mm ply is very useful for columns because columns are vertical members. 18 mm ply can be used to fabricate formwork with timber backing and using bolts, tie bolts externally to hold column and supports. Column form contains fluid of concrete. Fluid of concrete means a liquid, means it will give a pressure to column forms, and maximum pressure would be at 1/3 height, casting height from bottom. At that point you have to provide good support, resistance support, maximum supports. So you have to support it at bottom, you have to support it at 1/3 of casting height, and you have to put fixation of your standing at top where your dimensions are come. This is general arrangement. Then you have to check dimensions, top dimension, bottom dimension, and then to ensure plumb at least 2 sides, if not all 4. That plumb should be within limits. 1 millimeter in 1 meter height, not more than that. This maximum. It should be in plumb actually, but it cannot be 100%. So tolerance is 1 millimeter in 1 meter height, not more than this. So in 3 meter heights you can expect a tolerance of 3 mm. In 4 meters 4 mm maximum. You have to raise your platforms for working also. When you are doing form work, you need complete platforms when people can go and work there. So it takes time, because you have to fix bolts, you have to do everything, you have to set dimensions, you have to set alignment, you have to check sizes, you have to check plumb, and these sizes must be taken from axial building axis. That should be your control point. And then you check dimensions of column and all this isolo verticality you have to check, and you have to take everything. And you have to inspect also your way or procedures. Into that I'm not going. I'm just mentioning here activities that should take care of. So what happens now? Let us say you tried for 20 columns to cast one time. It depends upon your repetition way, because if it's 3-4 story, you can buy formwork for all columns and keep ready. You have to construct temporarily working platforms for pouring concrete around your columns. That is a must, because you cannot fly in air and pour concrete. You need platforms to work, platforms with railing, handrails, and you have to put ladders also to reach to that platform. So maybe there are 3 rows and you have to put platform everywhere where you can work your stand on that platform. You can put vibrator there, you can stand there, you can move here and there without any accident. And remember, you are standing at height of 3 to 4 meters. So you can fall. So you have to take all preventive measures. Though concrete will be done only a few hours, but it takes just 1 second to fall. So that temporary arrangement you have to do according to safety engineer's advice, because safety engineer is also there to make sure that this platform works. So your vibrator should be there. You have ordered concrete, everything is okay, everything is fine. You are ready for concrete. Column concrete is very slow. It's not too fast. Even you get one mix, which may take 2 hours on site, you have to be careful. You are getting mix from ready mix. Do not ask for complete quantity in one go. Or if you are forced to get complete quantity, you have to do it fast in rotation. Example, let us take a 30 centimeter by 50 centimeter. It's 0.15. 0.3 into 0.5. 0.15 square meters. And height is say 4 meters. 0.15 into 4 is 0.6. 0.6 cubic meter. So in one column there is only 0.6 cubic meter, or say 0.5 cubic meter. Only half a cubic meter in one column. And there are say 10 column or 20 column, you calculate yourself. This is in 10 column, it's 5 to 6 cubic meters, and in 20 columns it's more than that. You know quantity, how much you have. You cannot get this in many. You will get only one transient mixture enough for you. But you have to see time of pouring, because you cannot hold concrete for many hours. You have to pour in layers, maximum 400 mm layer. And if it is say 4000 mm high, 40 or 400 mm layer means 10 layers it would take. If it is 300, accordingly it will take so many layers. So number of layers in one column and number in all column, you have to assess yourself. So ask concrete accordingly. Otherwise you cannot hold that mixer for 4 or 5 hours. That is nonsense. That is waste. Or if you have permission, you can mix it on site using your weigh batcher. You can use your weigh batcher for this type of concrete work. You can do that. You are now ready with concrete. Concrete is there. You are using it by crane or by a pump. By whatever mean, pump is not easy. But if you get pump, that is very good. You get pump. You have pump. That pump boom can go to bottom of or at least to 1.5 meter above bottom, because up to 1.5 meter you can drop is permissible. If it's 2 meters or more, it's not permissible. So you have select maybe smaller pump for this work, or it depends upon you. You are using tower crane or you are using mobile crane. Whatever you are using, you have to decide accordingly. Only thing, drop height must be maintained. It is up to 2 meters, but let us say 1.5 meter. Your pump boom should go down to that height only, and your vibrator must be down. But vibrator should be there only when there is no pump boom. Now vibrator is out. You are taken your pump boom down, pump chute down, and it has done concrete say 400 mm or 500 mm. Let us say 400 mm. You have to be careful about that. Stop immediately, take to another column, or hold it there, vibrate it. When it comes out, this boom, keep it on another column and pour there. There should be another person, remember, another ramp. So you immediately vibrate this 400 mm layer, immediately, don't wait, and then go to other one. So one vibrator is not sufficient. You must have at least 2 vibrators for this. And you take this pump accordingly. You are taking whole row of 10 columns and do in layers. Then come back and do second layer and vibrate immediately. This way you can go So you will move in make over shifts here, and come back. Do it and come back. Column concrete would take time. It's very big technical activity. It's not layman job. You have to vibrate properly. You have to keep thickness of that properly, and it takes time. Because column fails means you fail, your building fails. Generally, I have noted this on sites where even they are not using full height, there is honeycombing at junction. It says column, here you will find problem, honeycombing or widened concrete and not properly in vibration or over vibration. All kind of defects are visible, and on major projects. This means our engineering staff, engineering crew, least bother about workability, about quality, how to manage. They just manage laymen, not professional men. And this is everywhere I have seen. Everywhere. Remember, engineering is done on site and not in office. When concreting, there should be some very responsible personnel on concrete supervision, concrete pouring supervision, or don't do it. If you are not engineer, you depute someone whom you have trained particularly in pouring. That man must know what is to be done, or else your concrete is not accepted. Column concrete is very risky. First of all, when it's full height, it may take, of course, few hours. It can open, sides can open. Maybe you have not put good supports, you have not used bolts. Sides should not open first of all. Remember, sides should not bulge. Bulge, I mean to say, it should be clear vertical, but it's not vertical, it's opening out, bulging. That is not acceptable. Number 2, pour in layers. 400 mm or that which your needle can accept, concrete needle can accept. Remember, second layer vibration should go down below. So just maintain 300 mm to 400 mm maximum, not more than that. And repeat, or stand on the point, let you fill 4 layers and immediately one layer vibrate, second layer vibrate, third layer vibrate, fourth layer vibrate at that point, and be sure your vibration is okay. Then move to next one and next one and next one. No harm in that. It depends upon that your concrete vibration is excellent or it's not excellent. But don't fill full. Remember, if you fill full, pour full, then you are not crew of concrete. If 4 meters, it should be gradually done, slowly it should be done. Remember, concrete sets in maximum 2 hours or 1 hour, and solid, as you have filled 1 meter, then 1 meter, then 1 meter in layers, after 1 hour it shall start getting stiffer, start getting setting, and it will not give full pressure on your timber or plywood. So column is done that way. In layers and in heights, you have done column, and it's perfectly right. Shutting is in position, steel bars are in position, vibration is okay, that's fine. And when you finish column pour, that day just cover from top by Hessian or by plastic. And if you had some dowels left, you have to be ready for that. Either place dowels in before concrete starts, or do not concrete above dowel level, just keep below dowel level. You have to decide. This can be a question for a staircase waste slab. landing slab, you cannot do all that in one go. You have to take column only up to landing level or whatever is there. Means you have to think for every other column how you have to move. That is why I am saying it is completely technical construction. It's not simply just concrete because I have done this. Concrete must be used, must be produced professionally. So concrete you have done for columns and you have covered from top up to, you can say, if you think it's very hot, of course you have to take cubes, that I am not telling now. You have to take cubes, take slump, all that you have to do as usually you did before. But only difference is in column your slump shall be lesser. It won't be more. It can't be more. It's different one. It's little stiffer because it's vertical pressure. It's vertical pressure. So you cannot, you have to think of many things. Do not increase, these people, crew members, no, wait for more water. No, don't listen to them. Because you are doing gradual concrete, you are doing in layers and they don't understand what is layer and what is full height. Column is very risky, remember. It has to be done with tolerance, with patience, and column at landing, column at lower height, column at towels, and column all the free columns. You have to do all that. And we have to be careful that these conduits, if there are electrical conduits for switch panels or something else, must be intact when you are pulling. All your concrete spaces remain intact when you are doing, and do not move steel from its position. Leave it where it was, but supported by concrete cubes. Concrete spacers. Concrete these spacers. Once you have done columns and you have started curing from top, what about outside? What is the formwork area? And you think temperature is there. Its temperature is hot. And you feel that it may affect. Then you have to keep your plywood outside formwork cool by spraying water if it is required. I am not saying done. If it is required. If you think nothing is required, don't worry. Don't worry. You are happy that you have poured column. Oh, I have poured column. Something has been done. Yes, you have poured column. You have to think further then. Time has gone, one day has passed, 24 hours passed, and all this time is moving. Your platform you have removed. Okay? You prepared temporary platform, you have approved, you have cleared all site, you have taken down vibrators, everything. Now you have started removing shutters. If you can afford, leave them for many days, no problem. You are not going to lose something. It will help you in curing. But if you think no, you have to repeat these columns, then you have to take them off. Yes, certainly, you have to take them off. Means you have to repeat them, rotate them to another set of columns and another set of columns. In that case, you have to repeat them, means you have to take them out from 24 to 48 hours. Now, it's column. It takes time to remove shutters also. It's not in 1 minute you can remove. Because you have to take out bolts. If there are bolts, you have taken out the sides, open them. Then once you open shutter, open your timber or your formwork, it's time for you to be serious. It may take, I think, more than half a day to remove one shutter, because shutters are heavy and you have to take them out gradually because you have to use them for some other repetition. Once it is out, go and see surfaces. Go and inspect surfaces immediately. If you find defects, you have to be serious. If it's defects free, okay, no problem. If there's honeycombing or there's some void left, These are all serious issues. We'll talk about them later, how these are done. Because I don't want to confuse you. Just now imagine that concrete is very fine. It's acceptable. What should you do? That's the point. We'll talk defects later on. No problem. But just inspect that. Inspect that and deal with your consultant or yourself if you yourself a consultant. How to handle this. Now let us assume column surfaces are fine. It's okay, admissible. So what should I do? I am happy with my surface and my whoever is supervising that over me is happy. Okay, fine. Then I should do curing immediately. Two ways again. I will prefer curing compound on columns. My preference is that. Your preference may be water, it's up to you. If you have plenty of water, you may say curing compounds very expensive. Well, expensive or no expensive, you have to decide. You can calculate cost of water and cost of piping, person who is staying there and doing this, and cost of Haitian, all that. You have to think of that. And water curing compound, you compare both, and convenience also you have to consider. Now let us say example of curing compound, application of curing compound. I have decided to use water-based curing compound. I have decided water-based because of some reason, not wax-based. Why? Of course, water-based is little lesser affected than wax-based. But my problem is another one. I can manage this water-based. First listen, what's procedure? This surface is removed, shuttering is removed. Spray water on that. Spray water on whole surface. And immediately spray curing compound on that. Complete surface is sprayed with curing compound. No place is left. And leave it after that. I am telling I use water based, not wax based. Reason is, in water based, there is no problem in future because it will be off. It will go away in few months before plastering or rendering is done. Plastering or rendering is done if it is to be done. Plaster means internal surfaces and rendering means external surfaces. We have now removed shutters and applied curing compound if it is water based, and if it is wax based I can apply that also, it's no bar. But wax based cannot decompose itself. Problem is that surface or membrane of wax formed on column surfaces cannot decompose, cannot degrade itself, because you have to apply plaster on that or some other finishes on that. For that purpose, if you apply wax based, you have to apply degrading compound on that or debonding compound on that or something available according to inquiry with chemical manufacturer. Because it may take 6 months sometimes, but you have to do it early. So you have to use or waste water based. If you do not want to use curing compound, then simple way is use your gunny bags or Haitian bags saturated with water, wrap around on your column surface and cover with polythene sheets, either using binding wire, roll or something, so that these stick, and top cover also, so it is inside wet, and flooding it in future, keep flooding. Water should be there all time, but this is not done anywhere. I have not seen done like this anywhere. So your water goes waste, is evaporated out, and you do not understand this. Once there is this is cloth cover, it will at least benefit you of use of water. It will prevent evaporation of water when your plastic sheet is placed on that. That is important one. So there are two ways, as I explained to you. This is for column surfaces. Now you have curing ongoing, but you are carpenters were instructed that start leveling for beam, for super slab, I mean to slab, whatever beams, soffits and vertical size, they have started fabrication, and that activity is moving separately. You have given them lines on columns, or they are fixing temporary level unmeasured, which can be later adjusted after once your column curing is over. And so your guys are working, your carpenter formwork crew working on your beams, bottoms and beam sides. And also you have system for your slab support. That system may be your prop jacks or your scaffolding system or cup lock system. Generally nowadays cup lock system, that is very easy in installation and having much strength than your wooden bullies or your props. Maybe it's very stronger, but it needs certain care. It needs your drawing and fixing them into spaces. But that is very strong one, and these days that is done. If it is done, it's fine, it's welcome step. That centering and supporting, we call it supporting. Your those people expert in this system, they are busy there in doing this, and they did all ad hoc work, temporary work, involving themselves and start laying your portions of slab beam supporting system by whatever means. I will advise that do not do it yourself by your own designs. Better they are proprietary suppliers for such systems, cup lock system or some other system. Discuss with them, show your drawing to them, and let them give you this material on rent, and use that material according to specific design of your drawing. They will give you same material. They may also give you drawing how to fix it generally, and blow your waste slab of steel and follow that. That system is much stronger than your timber bullies or wooden bullies and than your props, because this is well braced, this is well connected at different heights, and it's much more stable. You can use 12 mm ply for this slab and 18 mm ply for vertical members, or you may use 18 for all. It's up to you. If 18 is no problem at all, you can use 18 for all and use tie bolts and beam, and you can connect to beams, column top, some portion which is column neck. So all this shuttering is now worked on, and you have removed your curing arrangements. You have give datum line on these columns, any datum, fixed datum, which may be from plinth level 1 meter or 1.5 meter. You can fix, you can make a line on that column, and all datum line should be made on or marked on all columns, from where you can measure your beam top or slab top. That is what can be done. It's no problem at all. When you do that, you have to ensure levels of your beam bottom, that is called beam soffit level, and slab soffit level. Slab bottom means slab soffit, and beam bottom means beam soffit. You have to use your level and leveling staff for this purpose. You do yourself or you ask your land surveyor to do this, and you check level at all locations, at least 3 or 4 locations below beam, and at 1 meter wide, means at various locations on your slab bottom there should be equal levels. And if you have allowed some camber, you can use that if you think it's fine. If not required, don't worry. It depends upon what sort of design you have. If you have ductile design, then there's no mandate on that, you can do your way. But leveling is specifically done, must be done, and you cannot ignore it. It should be done continuously from time to time, and they keep working beam bottoms, beam sides they will do after placing a steel reinforcement on that, but slab bottom and all that they have to do according to your system design. And another gang must be working on your reinforcement fabrication. Once this slab bottoms are ready, beam bottoms are ready, they will come with their prefabricated beams, I mean to say pre-assembled beams, or you can assemble there itself and place in position beams. Design is there, and as I said before, you have to protect it and you bring it to, they do beam work there. Do not close your beam sides before beams are done, beam reinforcement is done. It's very fast, it doesn't take much, because they are working in parallel and they have complete details, and they fabricated rings before and they bent bars before. Now they are just assembling them. They assemble them now. They do it. What to say then? Let us assume beams are ready. They have put covers below beams, sides beams, and they say, okay, you can close them. You have to inspect first, remember. Do not close it. Inspect each beam according to your details in design. Each beam, how many bars are there, top bars, bottom bars, side bars, ring spacing, everything you have to check, inspect it. When you are satisfied, get another inspection if done, if required to be done by some superior or by circumstance someone else. Means whatever procedure there, you can complete this beam and beam work. Then you can instruct them if you want to close if required. Remember, in beam there must be tie bolts, and there must be, I'm talking of drop below, drop beam drops, tie rods must be there if they are deep beams, and wherever support is required must be there. It depends upon your design. Now beams are fixed in, then they start for reinforcing bars. Reinforcing bars of slab you have started, and they are doing, these are not very slow, this is very fast one, because generally bars are symmetrical, and they do this work of fixing reinforcing bars on slab. And then don't wait for electrical guy, let them come and do their job. If work is to be embedded, still the conduits are to be embedded, let them do job, and you try for second layer or upper layer. The electricians shall take some time in doing this job. Let them take time, let them fix their boxes, junction boxes and their conduits and whatever is required, and your AC blockouts to be fixed by AC persons wherever it does, or plumbing blockouts and whatever is, then you do that. Whatever services are there, embedded services, inserts we call them, all inserts must be here, and then inspection of this be done by services engineers, and after approval we can continue. So second layer of steel you have placed, everything you have checked is okay, sides you have done, slab sides, and you are cleaning that, everything is, means you left some pocket there, some, you can say side open or something, means you can clean everything, and you think that you are going to pour it soon with external scaffolding system ready, and access to that level is ready. Remember, your stair is not done yet, so you have to use temporary access somewhere. Your stair should be done separately, same way. give layout of the system, horizontal layout, vertical layout or inclined layout, and prepare it that way. Of course it takes a little time because stair is not that fast. You have to provide waste slab as well as formwork and steel for steps, so it takes some time. But phenomenon is same. So you think that you are ready for a slab pour with first waste, okay? You are ready, that's fine. You have to do everything, inspect, and you must have placed the order for concrete before, because it's not only you are buying, maybe there are many people. So you must have kept that order before. So now you say that I am ready with my slab. Whatever inspection is done, if it's required per specification or per law, you do that. All inspections must be conducted, remember. Now you must be sure that you are interested to call that proprietary system party from whom you buy the scaffolding material, and there's agreement with them. You can call them for inspection and let them inspect. And if they say yes, it's okay, you can take in writing from them. Now slab pouring of slab. Everything is ready, everything is fine. All inserts are there, all steel is there, all concrete spaces are there, everything is there, all columns are connected to slab, and your time also starts then. Maybe you want to check levels again, no problem. You want to check what you want before again, and you plan its pour. There may be many complicated steel reinforcement places, there may overlaps or there something, you all do that. You have to make sure that bending moment transfer bars are also there. I mean to say beam and which goes to column, that junction where bending moment from beam goes down to column, those bars must be fixed if it's not shown on drawing, and it should go down with overlap, and same should happen on all details. You have to be very careful on this slab cum beams monolithic concreting program. You have planned it. You have worked out quantities of concrete, total quantity. You already discussed the order play, all this, have placed this program with your batching plant owner or batching plant operator. It's not bad. It's good. It works like that. Now you have to tell your batching plant person about program. Date you had already fixed, quantity you already told. Now you have to see how can you do it. You have told him that this is slab form, this is thickness of slab, this is mixed grade, and that person is ready. You have to give them program, what slump you need, and design of trial mix that guy has. Frequency you have to tell at what frequency you should get this. Maybe you have 200 cubic meter concrete there, maybe 500 cubic meter concrete. It's your program. How you want to move that? How many concrete pumps do you need? Maybe you need 2 concrete pumps or 3 concrete pumps. It depends upon availability. You may say I need 2, I need 3. If it's big one, it's up to you. And I want to finish this pour in 8 hours or in 12 hours or in 16 hours. According to machines available, batching plant may be giving you 35 cubic meter per hour, not more than that. It may be giving you 30 cubic meter. It may be giving you 25 cubic meter per hour, and you have 200 or 300 cubic meter. So you can divide with that and giving all considerations or all lapses. You may say it may be 8 hours, it may be 10 hours, it may be 24 hours, as you say. Or it may be for 3 days, for 4 days, it depends. Or you want every transmixer a gap of 10 minutes or 15 minutes or 5 minutes. You have to plan accordingly. And there must be people there to supervise them, personnel required. Quality engineer, safety engineer, foreman, all, and number of vibrators and everything, and water, everything you have to be. You must comply with your checklist, what you had, and your 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 batching plant must be ready with everything, because this is slab, this is big material, big element, and if there's breakdown, what solution do you have? If your vibrators breakdown, what solution do you have? And in utmost case, when there is stop of concrete due to certain, how you will make way for construction joint, immediate construction joint. Everything you have to take into consideration professionally, because this is concrete, and then only you can say yes, we are ready, with supporting system is fine, external platforms are fine, and everything is fine, and then you workers should be ready. If you want to do in morning or you want to do at night, wherever you want to do it, your workers should be ready, your staff should be ready. If you can do that, you can say, okay, we want to start concrete, maybe early morning hours or maybe early evening hours. You start at 5 o'clock, say in evening, and go throughout night, depending upon temperature. If you say, no, it's good weather, I can do in morning, okay, do in morning. No, it's very hot, I'll do at night, okay, do at night. You can start even at 8 o'clock at night, you can start at 7 o'clock at night and continue throughout night, no problem. To an extent, work is done in an acceptable mode. Remember, you must be ready with top level of concrete. You must be ready with vibrator. You must be ready with all masons, number of masons required. You must be available with a substitute crew, active crew in waiting, because it's hard work. You have to provide rest pauses to people after working 1 hour, 2 hours. You have to provide them some refreshment as well, because it's not easy work, it's difficult work. And remember, you have to provide only as many number of workers on slab, not all. Some people should be on slab, some people should be down in shop, and some people will be somewhere on your site. So you can, if it is night, remember, you will need lights, electrical lights, flood lights or whatever lights at every location. Where even slump is taken, their location, on slab itself, or wherever you people are working, below your slab, means where there are props or supports, and everywhere in lighting arrangement, and throughout night. It's not direct light done by generator. All these must be there. Your concrete order has gone, concrete has come, and you start taking tests. Quality engineer must be there. Safety ask, they must be there. Everybody should be ready. There should be some carpenters at supports, at beam supports, or some other supports. Everything should be intact. And remember, you don't allow excessive people on slab, and don't allow, only those people should be there who are required. And you have to explain procedures of vibrators to everybody, how they have to do it, how they have to place concrete mix on. What happens sometimes, people just keep on putting discharge of concrete here up to some height, say half meters, and I have seen 30-40 cm fills there. No, don't do that. Immediately take it. Start from beam sides when it comes, after slump is done, everything is done. Start from beam sides and keep on crew moving. Don't hold mix at one place. Move very fast. If your crew places, move very fast on the whole beam and rotate everywhere where you are thinking 2 hours or 1 hour will be here, and pull it into beam very fast. Fill half beam. Vibrate, go on vibrating, don't hold, and rotate all beams, then come back. It may be 1 hour, 2 hours. come back. Start again, fill full beam, and come on slab, keep on moving, come on slab, keep on moving, come on slab, keep on moving, and instruct your bar bender if something breaks there, if block is replaced, if binding wire is broken, immediately they have to repair. Immediately keep our watch on that. Close supervision is required. Instructions to carpenter for shuttering, vigilance, instructions to steel fixer, instructions to masons, and you know what sort of dress they should have very well, gunny shoes and their dresses and everything. That is safety point of view. A safety guy shall take care of that. Let him be responsible. So you have understood sequence. In your method statement, you must have taken one pump will be this side, one pump will be that side, it will be located there, here, and this mixer should be here, this transit mixer, maybe your 2 or 3 transit mixers are working same time, they are offloading, and there may be a sequence of 3 or 4 transit mixers in chain, this end and that end, maybe you have 6 or 7 or 8 transit mixer together at site, and you are emptying in 10 minutes or 5 minutes one, and goes washing, the other one comes and goes like this. Your sequence is moving, your activity is moving rapidly. This means you are working on vibrators also rapidly, slab guy is working very rapidly, cubes are being taken very rapidly. Everything is in flow because of big concrete. And you are placing it twice in beam, then on slab, 15 centimeter slab or 20 centimeter slab, depending about 30s or whatever it is. You have to apply vibrator everywhere. Yes, if it's 30 centimeter slab, it's 25 centimeter slab, 20 vibrator application is a must in slab also. And of course in beam you are applying twice, half your vibrator and second is like. So this way you can move in a planned fashion, professionally, to place concrete, to pour concrete onto your prepared system successfully. If you move without any causes, without any probe, you can go on to see whole concrete down. Just make sure that you do not ask for additional concrete, no need, because whatever you do, you concrete, that is fine as everywhere. Means you have done successfully your concrete work. But remember, your work is not finished. Too much hard work your people have done. You have been standing full time, your foreman is standing full time, hours and hours and hours. Then your masons are working on finishing. Spray compound immediately if you have. Don't wait. And if you don't have, you are using just polythene sheet, immediately lay polythene sheet on that. Immediately don't wait. And to cover all. Then wait for hours, because it may be 2 hours, 3 hours. Saturated gunny bags should be spread once concrete is solid, to some extent set, by taking off polythene sheet, cover with saturated bags, and then recover with polythene sheets. So polythene sheet must be there above your Hessian, and Hessian should be above on surface of slab, and keep it watered in. Keep it watered in. Yes, meanwhile you can take some, next day you can take some dune sand or something around the edges and fill water in, and what must be this saturated, this Hessian should be saturated, should remain saturated all the time, and polythene cover on that, and you are curing continuous like that. And you remember that all those bars on column, of course, protrude on first slab, first place, first slab, or then you have time for curing. First day, second day, third day should be, you can say, plenty of curing. Flooded curing. Then now you have to think for above columns. Above columns, meanwhile you have column from previous below slab, you will remake that after taking off, you'll make them, strengthen them if they are twisted or something, and clean and all that, and you will make for above floor. You can do that. And columns, and you have to make external platforms for working. And same what you did for ground should be done for first floor, but remember in first floor you may have balconies, very heavy balconies you may have. You may do that, accordingly repeat it. But remember, formwork of balcony is to be taken care of. You cannot remove shuttering of balcony immediately as you remove other shutterings. It takes time. It's more than that. Maybe 3 weeks, maybe something. If it's built balcony, maybe 4 weeks. It depends. So this is basics of pour of, you can say, diaphragm slab. We can call it diaphragm also. We can call it diaphragm. Its action is ultimately diaphragm because this is the ductile member. Now, generally, double reinforcement is used, 2 meshes down and upper with equal. For example, if you are rating 8 mm bar in bottom mesh and in top mesh, or 10 mm bars, because that compression still can also be used. Of course, you have to provide reinforcement on all beams. Better completely provide it, so that it becomes a beam. A slab becomes a beam in itself. Compression still can be considered for deflection control. I mean, to the bottom steel is there, but if we completely cover with minimum diameter bars in both bottom and top, so it can be like beam, large span, less thick beam, or thin slab, or thin diaphragm, that can help you to some extent ductile controls. That can be done. Means you have to think that way. Now you have done this slab, and your curing is continuous, and you are working on upper layers. Same way it will go, there is no change. Only thing overlap you have to see, or if you are using your mechanical connectors, you have to provide mechanical connectors. It's up to you. There is no bar on anything. You can do that. You see how much strain you are having. Many people would come to see what you are doing, how your slab cured, all that. Many would come. Client guys would come, owner would come, somewhere, because the slab is big job, is first slab. They will see how competent you are. Maybe you are celebrating, celebrate, no problem for celebration, but you are tired. Of course, that day actually nothing happens after slab is done. Then people come next day, and because they forgot everything, cement is set on steel, and subsequently they have to brush out everything. They sometimes forgot even to, you can say, brush wire your connections at slab and this column area. They forget so many things. They are tired at night and move this morning just to do it and run away. Well, this happens, you can't stop that. Well, but at least slab has been done. You can scavel that joint, no problem. The joint at slab and column junction, where new column has to come up, you can scavel that or chisel that out so that it is clear and roughened out, and all your exposed aggregates are seen. You can brush out all cement from your steel bars, and you can do so many. You can brush out that, and you can even put additional upper steel there. You can start your scaffolding system, your working platforms of your steel reinforcement, and because your steel is already, you can start that activity. That's not a big deal. That can be done because your concrete is set already. It's hard. So you can start that. You can arrange working platforms, and you can take up your scaffolding upwards, so that it will take time for still fixing, and meanwhile your bottom, you can remove your vertical portions or beam, or if you want to repeat them, means leave it, it doesn't matter. We have to repeat same thing over and over, and you have to take care of stair also, which was not done. You do that, or if you are done, you start working for other one. All this activity can go in repetition if design is same, even up to any number of steps. And also lift, had it is a lift, you have to take care of lift also. That's very important. Lift, if it is in building, every floor is there, lift is there, then you have to take care of steel and formwork of lift very carefully. It's a big job. It's very big job. It's a door in. You have to take separate scaffold for that. It's a void actually. Lift door is a void for concrete. So it is double formwork there. Internal formwork. It has to take from internal, stop concrete from wall. You get my point? This is a lift door, which is a double shutter. You have to make a different design of shutter so that it resists the wall of concrete which is there. Lift is different treatment. You have to be very careful about that. And if possible, do it separately, no harm. If you can do it, or you do it with same, it's up to you. But it's very complex work. Lift well is called. It's tough work. There may be one lift well, there may be two lift well. It depends upon how it is that. So one story you have to do it, then repeat it. If it is symmetrical, no major design changes, that is where engineer is required. It's not play, it's no game, it is professionalism, it is professional work. Your joints of formwork should be very well, no leakage, no opening of shutters, no level difference, everything must be intact. That is what is engineering. It's not simply that I've done it. No, it's not that. And how to take out shutters, how to check, everything is very much concerned. That is why I am very serious about what's happening. People are not serious. Here also thing I tell you, this is what I explained to you about complete cast in situ. If you have planned for prefabricated panels for slab, you can go for that, no problem. Column you would do same way as I did before. Beams on which these slabs would rest, these panels would rest, would be done in same way, with details. There's no difference cast in situ and cast in columns. This can be done comfortably. But you will bring prefabricated panels and place according to requirement. But remember, this must be converted to diaphragm, because this is separate panels. Prefabricated panels, hollow core panels, these are pre-tensioned one. These are pre-stressed one. Industry produce or factory produce, these are smart one, no problem. But you have to transform this to diaphragm action of slab, and generally 50 to 60 mm concrete is placed on that around with reinforcement, so that whole cores and this cast in situ topping acts as diaphragm. Means it has same result as your cast in situ. This is done here. Thin concrete, thin with steel, to convert this separate panels into diaphragm action. That is only difference. But only benefit is, in this case of precast or pre-stress, formwork of bottom of slab is avoided. There is no need of supporting system except in beams and columns. slab is free to do. You have just to place these precast panels. You have to raise to that level and place. For that, mechanical arrangement is required, machines are required, transporting trailers are required, of unloading from factory and downloading at site and raising to that level is required. All those are activities which are exchange of formwork. Site remain better, you plant there all this and convert to diaphragm. That is all. But you are spending on machine, you are spending on yard or your factory, cost may be different, maybe more, but time saving. They are using they are making their in factory, but on site you are saving time. So something is spent somewhere and compensated somewhere else. That is what we work about. Well, if you understand this point, I think you get something. I have talked of something today. I will talk of something tomorrow also, or whenever I get time about this, because quality is very important. Quality means not tests only, quality of system. This is what I am explaining to you. Quality of performance. Here quality is managed, prosecution is managed, material is managed, metal arrangement is managed, and workmanship is managed, and people are managed, and machines are managed. Everything is managed. This must be actually in writing. But you think, when I am taking 3 hours in talking, how many hours shall I make in writing, and then editing, and then sketching, everything? You can take yourself. It takes time, and who has time to read? Problem is not, even if I write, people shall not read. So what is use of writing? No use of writing. And this is only 3 hours today. It may take many hours and I talk of all activities. Well, it is work. Means something is to be done, must to be done. Well, with this, thank you very much. I'll talk next time whenever we are free. Thank you, gentlemen.